Alright, good morning, everyone. Alright, so today's live stream, I'm going to go over the GTX 460. I need to reflow the memory chips. I'm going to reflow them all really good. Maybe I didn't do as good last time. I also did put a lot of pressure towards the core, which could have flexed the board again. And it's a little bit artifacty when overclocking, and it shouldn't be. So I am going to reflow it and add on a few more mods onto this card, and we'll see what we do. We will see. I would like to re-add on the voltage control for the core again. It is on air cooler, so maybe I won't do that because I want to do some testing for air cooler, do a bunch of benchmarks for a game of some sort. So we'll see what we can do with it. I know we can play a few games with this card here, but on the air cooler, no extra voltage, it just does not work. And this is the card, like it's just a blower style EVGA GTX 460, so definitely no good for extra voltage. It does undervolt very nicely after I redid the MOSFET, which I'll show you here. The MOSFET's working pretty good, and it does undervolt very nicely. Stock is 760 megahertz at 1.037 volts. I can do 900 megahertz at around 800 to 850 millivolts, which is really, really good. So very happy with that. The mods are very, very good for this card, and I'm again very, very happy. But I would like to add on some more mods, probably add on a few more caps, whatnot, whatever I can to this card. And I would like to add on a few caps to the core. The memory is probably alright, but I'm going to add on a bunch of these 0402 caps and see how we can get from there. So what we're gonna do, what I'll do here is just wait for some people to show up, and we will get at it. I'm just gonna drink my coffee and relax. Also, we'll be using a different soldering tip. I got it all prepped up, ready to go. Just gotta get it heated up right now. And we'll take apart this card. Again, I've already reflowed the memory chips. Probably not the greatest. I'm going to preheat the board pretty good and then hit it with some hot air and the memory chips to see if I can reflow it a bit better this time. And probably, maybe I won't put the stock air cooler back on the card just because it does flex the board a bit and probably is causing the issue with the memory. And that's it, just 4 screws. 4 screws holding it on. That's it. And then what we can do, grab the back, flip it forward, and there's the contact. Not the greatest for the core. That's the best we can do. And I did delit it, but can't seem to make better contact than this. I would have to do something with the actual cooler to get it to go farther down onto the core, make better contact. Hey, how's it going, Super? So I might have to lap the actual cooler with these mounting spots. There's 6 mounting spots, well, 8 mounting spots total. that would have to technically lap down. I'll check with a straight edge here and see if these spots here, show that a bit better here, see if these spots here, these 6 spots, are higher than this spot. If so, and I don't think so, I think it should be around flat all the way across, I would lap this cooler down so that way I can get rid of these ridges. So that way we can make better contact. But I will clean up this board. I'll clean up the memory chips, because if I heat these up with a little bit of solder paste, it's basically permanent. So I'll have to clean it up. So that will be the first thing we do. Gabby's currently in bed, sleeping. So we'll clean these up pretty good. And we'll just give the board a nice little clean as we go. I think sometime next month I'm going to try to get some new flux to try out. Some clear flux and some higher boiling point flux. It's better for these little repairs that I do on some of my cards. So this card here I fixed up. I fixed up a lot on this card. So when I first got this card, it did not work at all. It basically would turn on. You can see like the BIOS screen, and then would basically instantly turn off because of the artifacting. And what I did to get the card working was to reflow the memory chips. Okay, so I reflowed the memory chips, and after that, after I got it working, I started doing a bunch of mods to it. Let's get that wire out of the way, hopefully, maybe, possibly, maybe not. There we go. So I started doing a whole bunch of mods to this card. It's basically got almost every single mod. It basically does have every single mod you can think of for this graphics card. So these were bare spots for tantalum capacitors. It has extra caps on the core and memory chips, and everywhere else I could add basically more capacitors. They're not bent, they're just laid out that way. So they're stacked on top of these ones. So the terminals go through the board, the through-hole capacitors right here, these 6. And then these 6 are piggybacked basically onto it to give it more capacitance. And they're just on an angle. They're not bent at all. They're just on an angle. That's how I soldered them. So that way I can lean the board over, I can do whatever I want, and I don't have to worry about these actually bending. And I made sure the terminals are very, very short, so that way they work more properly, basically. But yep, that's how I have them laid out. So I've added these caps because these spots were bare. More caps on the core. The core is also part of right here is like for the memory. I can zoom in for you too. Nope, this is all self-taught. I am a redneck from the woods, buddy, and this is all self-taught. So I'll zoom in here so you can see better here what I'm talking about on this stuff. So the core here, extra caps, as you can see. The memory here, more caps. These caps here that you're talking about here, these ones right here, I put them on, and they're just on an angle, so that way you can literally don't have to worry about them. So this one, as you can see, is touching the board. This one here is touching the board at this spot here. So here, and here, as you can see. So they're leaning on the board, and then these ones are leaned on those. So they're also leaned on that, that's leaned on that. And if I wanted to go a step further on that too, yep, self-taught. If I want to go a step further on that too, I can add like a little bit of hot glue or something to these ones, and then also to the back of it. But I don't worry about this. This is solid, solid, solid. As you can see, the joints, I made sure I put lots of solder just in case, so that way they don't, just in case they do move, they don't crack. And then more caps here on each of these VRMs. So these caps go to the VRM. I've also, so this card here, I did blow it up. I blew it up because I did a Furmark test after doing all the mods, and then after a certain mod, and I was wondering if that would cause issues. It's my fault. I didn't add any cooling to the VRM, and I should have. So I did this live stream. I replaced a MOSFET. I figured out what the issue was off stream, but then I replaced a MOSFET on it. This is a Dr. MOSFET, DR MOSFET. So you got, so this one here, so these ones here, you got source, 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 and then gate. So this one pin here, and it's this pin on each of them. This pin here is where your voltage goes out. And this is two high side, one low, oh, this is two high side, one low side, yes. So one of these chokes or inductors, whatever you want to call it, choke or inductor, is a VRM. So one, and then these two caps are decoupler caps. They help filtering the voltage that go from this to the rest of the card. And then up here, this choke or inductor, whatever you want to call it, this VRM stack, with MOSFET stack, sorry. So like one low side, two high side, sorry, it's two high side, one low side on this card. So one low side, two high side, choke, and decoupling caps go to the memory. But also the memory, so the memory voltage is in the core. So a MOSFET takes in the voltage, and then dissipates it to the proper voltage after it's talked to the chip. So this right here is an NCP5388 PWM chip. So this right here is the brains basically of it, telling the board what the voltages are, and you can modify it. Like I'll go over the modifications done. I've modified the resistor divider. I've done every single mod you can think of for this card. So, but yeah, it talks to that. And then if there's not proper voltage, it won't talk to, I believe, over here, the BIOS chip. This is a BIOS chip. And the BIOS chip has to enable to give the card power. But MOSFET's just taking the voltage, the 12 volt voltage, and making it into that 1.2 volts, or 1.3 volts, or 1.4 volts. Generally, cards nowadays, and most cards are going to be 1 volt, or 700 millivolts, all the way up to 1.1, and then some cards 1.2 volts. So, and that's what it does. And it's, your MOSFET will be different for a lot of cards. Its rating, so these are 30 volt, these ones here. This one's not. This one's not the same. So this one's a little bit different, but it does work for this card. This one MOSFET's just going to get a little bit warmer just due to the fact it has lower amperage. Also, each MOSFET has its own resistance too, so there's a lot that you have to take into account if you're going to replace a different MOSFET with the other MOSFETs. You gotta make sure they're roughly in spec. The only thing that's different with this MOSFET versus the one that was on it is just a lower rating of amperage. Still 30 volt, but it's only about a 40 amp and the rest of all these ones are 58 amp. They're 58.2 amps. These ones are 58.2, and this one's like a 40. In a way, more or less, it's going to not heat up as much. That's more or less. It's not going to heat up as much too. The stability is really going to come from your choke, your decoupling caps, your caps on here as well, your caps for your VRM. Your VRM, again, decoupling caps, which also will help the voltage, stable voltage. And then your caps that are on the core. These ones are smaller because it's by the core. You want filtering caps, like strictly low ESR filtering caps like these MLCC, or also known as a multi-layer ceramic capacitor, to be small and to be able to quickly transverse that voltage to the core. And to stack them, you are somewhat losing some, like a little bit of stability, but you gotta think each one of these is like a battery bank. But this battery bank can transfer voltage very, very quickly, as in frequency. So you have to take into account the closer you are to a core or your memory chip. These are memory chips. Closer you are to that. So these are like right there underneath the memory chip. The memory chip's right behind this. These have to be smaller. And then you got these larger ones that are a little bit farther away, but just go before the core. These are your larger battery banks. And then you got your really big battery banks. And then you also got your pre-VRM battery banks. All right. So your voltage will go in, your 12 volt. Your 12 volt will go in. It'll get stabilized with this first shunt, it's sort of an inductor, but it's more or less a shunt. These are more like shunts. And then it will go off from there to either the MOSFET, and then talk to the chip, to an enable pin. Yeah, there's a lot on GPUs. Not much has changed. More like we just get more VRMs. We get more VRMs. We get more MOSFETs. This card is an older card. It's from 2010, right? So this card came out in 2010. And yet this one has 2 high side, 1 low side, which is pretty wild. 2 high side, 1 low side. And then we got MOSFETs that do high side and low side all in one. And it's its own IC. It has its own logic that talks to it. It's basically like the chip on here that talks to. It's like one of these chips, but it's literally a MOSFET that it's like, oh, okay, well, everything's good. Let's just go. It's nice. It's nice that we have that. And then let's say you needed more power. Let's say you needed more power. You could do something like this, where you add in your own power source, because this one does not have its own power source. So you need to add in your own power source. So we got our grounds, the middle section here of your 6-pin, and also onto your 2-pin, but your 2-pin is a sense pin and whatnot, but your middle pin, your top middle pin or bottom middle pin technically, on this one here, so your middle pin is going to be your data sense. And you got to get rid of that. And then you got to get your grounds and then your power. And you can add your own power. So, And then I'll show how to do. I'm pretty sure I did this live stream. I'm pretty sure I did all the mods on this one live stream. This is an old 9500 GS. It's done very well. And then this GTX 460, I got a couple records with it so far. So I'd like to see how much further I can push it. So again, I replaced the MOSFET. Before I even got this card working, or when I got it was not working. Fixed it up by a reflow for the memory chips. Added on voltage control for memory and for core. Added on all the capacitors. And then once we go, so right here is right here. That's for memory. And this is just a feedback pin that I can control the actual voltage from a feedback pin. For over here, this right here is the NCP 538 controller. What I did there was very hard to see, quite small. So what I did here was short out these two pins basically. So even though I'm not touching the pins, these two connection points right here is I shorted them out, and ILIM and another pin. You got to connect them. You got to read the data sheet. You connect those pins, and then you can make it so it doesn't have any kind of overcurrent or over voltage protection on the card. So basically I can blow up this card now whenever I want. I have to fix up that one. I'll be doing that on this stream. But this right here is a resistor, part of a resistor divider, that if you add on a certain resistance, going from a 30 kilo ohm to a 20 kilo ohm, would give me about 600 kilohertz switching frequency. But I have a 10 kilo ohm, so it gives me 920 kilohertz switching frequency, which is basically the max that this controller can do, and is also the max that these MOSFETs can do. And that's also one thing you have to watch if you're going to replace your MOSFET, is switching frequency. So all these MOSFETs can handle 1 megahertz or 1,000 kilohertz. Right now the card does 920 kilohertz. So when you are soldering and you start shaking, even though I'm very good and I don't generally shake too much, it can happen. It can happen when you're shaking and whatnot, even though you got good positioning and whatnot with your hands and you're very comfortable, you can start shaking. For me, I find I start shaking more when I'm holding larger components like this. If I'm doing larger components like this power IC, and if I'm doing that, let's say I start shaking while doing it, like trying to set this in place or tape, basically setting in place to solder it, to start shaking. And just as generally the only time I start shaking is with these ones. But if I start shaking, I just stop myself. I'll stop myself and I'll just take a little break. Like give myself 3 to 5 minutes and go back to it, get myself comfortable and start soldering again. That's the main thing you need to do, is have a steady hand. So, and I can just hold my arms up and whatnot. I'm very, very steady, but even still, these larger ones, for some reason, with the tweezers, I start shaking for some reason with these ones. And I just stop myself. Give myself a little break. But these smaller ones, I don't know, I find it's quite easy. Like these 0608s and these 0402s, these 0201s, like these little guys, they're not even that bad. They're really not. And I use my eyes. I don't use like the screen or anything like that. I just look at the board and solder. But yep. It takes time. It takes time to learn, but once you start learning what you can and cannot do, and how fast you can do it, it starts becoming pretty fluent. I think that's like all things, though. also modify my tools so that way. So this is generally a straight, but I have a slight curve onto it, so that way I can hold the component nice and flat and also stay away from other components. Yep, and you know, if you don't want to spend money, I have videos out there showing like the cheap soldering hot air that I have, and I've been using it now. I've probably got a few thousand hours on it now, and it's still going strong. And the one that I recommend and have the video for, it comes with extra parts for it, like extra coil for the hot air and extra heater for the soldering iron. So it's not like you have to replace it, like, you know, buy a new soldering iron or hot air gun. You can just replace the part, which is amazing. And it's very cheap, and it works really good. Yep. You'll start learning. Like these joints here, I don't care about how they look for these ones. They don't look great to me, but they work, they're strong, and that's the main thing for these ones. The only thing is, if you make it so that way I stacked it right on top and I could make it look cleaner, it's just, it becomes more, could break a connection there. Yeah, no, not, it's cheap, but not that cheap. It's a good soldering iron right here. It's an 8898 60 watt ESD safe, good to go. It's a good soldering iron. It is. And the hot air, I mean, I've literally left it on for over a month straight. So the hot air, I've left it going for over a month straight. I like to test my stuff. And when I say I like the certain stuff, it's because I've tested it and I've put it through the ringer. Yep, this card's had the works done to it, everything you can think of, and happy with all the modifications I've done. What I want to do though for future is make a VRM heatsink for the MOSFETs, and maybe something for the inductors, the chokes here. The caps are fine, and then the memory, I don't have to worry about the memory. The memory doesn't take that much power, so it's not much of a worry. But these MOSFETs, I want to make a nice little heat sink for it, because I will be pushing this card. Again, got a few records with it, and I want to get a bunch more. I'm glad your hands are fine. All right. So I'm going to clean up the core. Clean this all up here. Yep, I've been very pleased with this. I've used a lot of different kind of soldering irons. Old plug-in ones. Then I had another soldering iron. It rest in peace, that one. Gabby knocked over a fan one day and it fell on top of it and broke it. But it worked all right, I guess. This one's very, very good. I actually really like this one. Let's clean up this. Really good. Whoa. And then we're going to start preheating this board. And all I need to do is grab the soldering iron, like a soul or hot air. And I'm just going to let that blow hot air on that. Yeah, take her easy, Super. Stop back in whenever you have time. I'll probably stream for quite a while today. Peace! Okay, so oh, look at my. I got this to let us know the temperature. This over. So put this. Yo, how's it going there, guy? What you doing, Nuggy? Hello. How's it going, good? Not bad? Good. You do any benchmarking this weekend, or? So, what I'm doing here is, I'm thinking when I put the car back on the cooler, again, the cooler is not the greatest. I pushed the back of the core pretty hard to hopefully get good contact before I put the screws in it. I think I cracked one of the BGA again. You didn't? Wow, I thought you would have. So I think I cracked the BGA again on the memory. So I'm going to reflow them again. I'm going to reflow them really good, preheat the board, and see what we can do. Clean up these memory chips really good. Now I just got a thermal probe in between these capacitors. That way that it's not really hitting heat from the hot air. Just gonna try to put some flux around it while it's warming up. Try to get some of it started to go underneath the chips. Ooh, that's a lot. We don't need that much. There we go. Drop down the air a little bit here. $69. Nice. And we're just going to give it a minute here to heat the board up a little bit more. I'd like to do it around 75C. That way I know I don't have to put too much heat to these memory chips. Good. I can tell this flux is getting old. We got a couple of hard spots in it. Basically turned it into hard rosin. Crystallized a little bit. Almost at 75. Let's go. Okay, I'm gonna put it over here. Heat up this chip really good. I'll do it by hand. All right. And that should be a plenty. Let that cool down. We'll start cleaning it up real good. What's the problem with your 1070? If you let me know what's wrong with your 1070, I can let you know whether or not it could be beneficial. It is artifacting. So artifacting can be the memory chips, or it could be a component for that. Like a resistor. A resistor can do that as well, as in it's not given proper voltage. Unless you have a multimeter of some sort, it's hard to tell. I did a lot of testing before I knew what the actual issue was. And just due to the fact I knew what this, the cooler for this one, I'll show you in a second. I'll show you the cooler. Just want to get all this flux off. Old flux is not good to, not fun to deal with. So I want to clean it up really good. The old cooler is a blower style and they're not made very well, and yeah, a lot of issues with it. I just kind of figured that's what the issue was after I did the testing. Yep, it's gotta be the memory chips. I didn't even have to do like a memory test on it. I couldn't even really do much of a memory test anyways. Turned on artifacts so hard it turned right off. Yep, 10 years old. This is a GTX 460. Came out in 2010. 16 years old. Had someone drop this off on my doorstep. So I have an ad out for if anyone wants to donate hardware. And they dropped me this off and an old motherboard and CPU. I got this card, did not work, and got it working and got some records with it. So I'm going to try to get more records with it, but yeah, it's got every single mod you can think of done with this card. I was really hoping I let it cool down fast enough, but there we go. I have to heat that up. It's got every single mod you can do basically to this card. Go, should be able to squish that. There we go. Hit on there. That'll do, donkey. That'll do. Gotta let the card cool a bit more. Oh yeah, so added extra caps. These are decoupling caps for the VRM. Added extra caps for the memory chips. Added on more tantalum caps for the core. More caps for the core. Voltage control for memory. Voltage control for core. No overcurrent protection, over voltage protection, which is a mod, and I did the switching frequency. So a mod for the switching frequency from 270 kilohertz, and now right now it does 920 kilohertz. So the max this card can do. This controller can only do 1 megahertz, and it's doing 920 kilohertz. Let it cool a bit more if I do anything. Yeah, every single mod you can do basically to this card. That's how I'm able to get a couple records. I'm going to try to go for more. Probably around the end of this year, unless I can get the funds to make myself a chiller. Then maybe I can make myself a chiller. It'd be nice if I could, but if not, that's fine. It's already starting to get sticky. Oh no, I gotta go quicker. Dang flux. I want to get some new flux too, some better flux. Be nice. This stuff is just getting old. I've had it for about 4 years now. It's almost gone, but it's not going fast enough for me. Replaced a MOSFET on it too. Used water cooler. Yeah, I have custom water loops that I use. The Cold Canadian Air. So my hardware bot team is Cold Canadians. Guz in the team as well. We're top 3 best overclocking team in Canada right now, and I am a top 10 overclocker in Canada. Used water. No, that's not cold enough. My water chiller that I want to make will be able to do minus 40 C, at least minus 40 C is what my aim is for chilled water, if not colder. We're talking like a hardcore water chiller. But I never got to run this card chilled, unfortunately. I got it on cold water. I haven't, not below 0 yet, and I got 2 records. So I'm hoping I can get, when I do chilled, I should be able to get a bunch of records with this card, especially after the modification. The switching frequency modification on this card. Oh, holy, yeah, was worth it. Was definitely worth it. But yeah, if you're artifacting, you'll need a multimeter. You'll need to test the resistors for the memory. So the main one that you're gonna have to test here. Give me a sec. I'll zoom in for you. Do you seal the card with some kind of coating to protect it? Yeah, I only use Vaseline. I use Vaseline. Cheap and works. So, we got. Where is that? I see it. I see it right there. A bunch of flux. Big pile of it. Get rid of that now. I'll have to reheat up the card a bit. So let's see here, up here, you'll have a resistor, a low ohms resistor right here that you'll have to test. So you'll have to turn the card on and test this right here on both sides to make sure you're getting the exact same voltage from the in to the out. Because this is a 1 RO resistor, so you should have basically the same in as out. Or close to it. And then what you can also do is test it for resistance from ground to both sides as well. And this right here is the one you're going to want to look at. One of these resistors is a main issue with artifacting. Could also be a capacitor going, but more or less it'd be one of these resistors, which could be a 1 RO or a 000 or a 20 or a 10 resistor as well, which a 000 is just a pass through. A 00 is a pass through. 1 RO is basically a pass through as well. Exactly, yeah. Very little voltage drop. Basically like a shunt. Yep. Yep. It's just to make sure it has steady voltage, right? That's it. It's all it's really doing. Steady voltage. Not like these big beefy ones here. 1 RO. 1 RO. Yeah, no problem. No problem, man. Yeah, and if that's not the issue, you're gonna have to check your resistance on these as well. Just check the resistance. You don't have to turn the card on. Just check the resistance of each of these. And hopefully your multimeter is good enough. Yeah, for each of the memory chips. And just make sure you're getting the exact same for each one. And you're gonna have to do every single memory chip of its resistance dividers. The capacitors, just look for anything that might look like they're, burnt, darkened, the capacitors. Make sure, see if they're burnt or anything like that. Because one of them could be, kind of burnt out and it's still working because it's just a pass through and it hasn't fully gone to short itself. Because these caps here are strictly for, these are resistors, but these caps here are strictly for filtering. And check the back of the card too, right? Check the back of the card for the memory. Another good one, I guess, is your regulator here. These generally don't go though. Generally. I'm just looking for any issues with it, as in discoloration is the main thing. And yeah, if everything checks out, a reflow can be beneficial. I fix it with a reflow and then because I wanted to put it back on that air cooler. What I did, and I'll show you the air cooler here. And the blower stop. Oh, or I guess we're zoomed in still. So blower style cooler for it, right? And the crappy design of it, right? What I did was I put the card onto it and I pushed on the back of the core before I screwed it. I think that gave it a little bit of flex, and it either A, re-cracked it or made it so that way one of the ground points or voltage points kind of cracked or made it worse, basically. So I figured I'd reflow it again, and that should fix it. It was like barely artifacting when overclocked, but it shouldn't have been artifacting at all. So I'm pretty sure that fixed it up real good. And what I might do on this stream too, was thinking about modifying the GTX 610 up, you know, giving it extra power source, like a 6-pin, 12-volt power source. Was thinking of doing that. So maybe I'll do that. Well, we'll see. We'll see what I do. This card's pretty good for overclockability just on its air cooler. So I want to see how far I can push it. Then what I'm going to do too is probably add more caps. And I got to make a cooler for the MOSFETs, more or less the MOSFETs. The inductors, the chokes, inductors, whatever you want to call them. I'm pretty sure they'll be fine. It's just the MOSFETs. I want to make a single plate, big cooler for it. Big heat sink, basically. And then use these screw holes here and use that to mount it down. I would like to do that. I just don't think I can do any other mods to this card, unfortunately. And I have to add this back onto the voltage sense pin, which is, I think this, oh, you can't see that. So the voltage sense pin. So this wire here will probably go, I'm pretty sure it goes to that one again. I'm pretty sure it's the third one, or the second one over, goes to that. I took it off for testing purposes and because any extra voltage on that air cooler would have been no good. But I'll have to check. So I'll have to do some voltage or some resistance readouts and see which one of these resistors goes to the voltage sense pin. That's all I gotta do. And once I figure that out, boom, done. Yeah, that is about it. And then I'm gonna add some caps to the core. Maybe I'll do that now. Add some caps to the core. What's stuck in customs? Wow, there's really those are stuck in customs? Like what? Yeah, delidding them, man. It's worth it. The paste underneath is done. And if you want, I can show you a little trick to delidding it. It's actually not bad. Do you have um big clamps? Do you have like big clamps for woodworking? It's kind of odd to do, but I mean it works really freaking good. You need what I did was big clamps and a razor blade, and holy was it easy. I was struggling for so long trying to figure out a way to do it, and then tried multiple different ways with like razor blade, a chisel too. But I was like, okay, well, why don't I just set it up a certain way here and use a razor blade and a clamp, and wow, it was like a butter. So I've seen other people dealing them too, and holy moly, kind of brutal in my opinion how they do it. Like, holy. No. No, you're gonna need like a 6 inch or a 12-inch clamp. I don't know if you know anything about woodworking. A 6 inch or a 12 would be better because it has more pressure without having to squeeze too hard. They're not easy, dude. They're not easy to take off. The IHS is not easy. Like it's seriously not easy. And a big boy clamp man will is like, oh my god. I don't know why I didn't think of it sooner. I need some tip tinner. Tip tinner. Some tip tinner. Tip tinner to the rescue. Oh, so shiny. So shiny. No. Nope. No. Not in the Fermi card. It's a crappy thermal paste. It's like toothpaste. And because of how old it is, it's literally dust. It's like hard dust. It's terrible. Yeah, and indium solder is what you think of. Indium solder is not what you'd think too. Indium solder is like a tin, and it could have. It's very odd. It has some gallium in it, even though indium and gallium don't really mix. Uh, yeah, they do have a little bit of gallium, tin, and indium solder. Yeah. Yeah, yeah. I've had people try to tell me it doesn't have gallium in it because it doesn't mix into it. Yeah, but it still has it. The company still did it because gallium's cheap versus indium, which is not. And then they add tin, tin for the binder. Tin was used for the binder. to bind everything, the indium and gallium, and made it a little bit harder because indium's super soft. But then the indium's really good because the indium actually had flex. So that way, when you put compression onto the IHS with your cooler, you didn't crack the die. Oh yeah. I'm your go-to knowledge guy for everything PC. I need... Yep. Yep, Intel. Intel used it years ago, then they quit doing it, started using crappy thermal paste on their... Was it from their third gen? Third gen and up. Second gen had... No. Yeah, third gen and up till ninth gen they used crappy thermal paste like toothpaste. Second gen and below, and it only depend on certain cards or certain chips too. But yeah, that is the right one. Right, we got that. We got this. Get a little bit of solder. A little bit of solder in here. Hey, don't flip on me. Do what I want, not what I say. Do what I want, not what I say. Just need a better angle for the dangle. Oh baby, 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 baby. Ooh. Second gen to third gen when they switched to thermal paste was it was horrible. Yeah, yep. But also what I like to do with those second and third gen is delid them still, and then lap the dies because the silicon topper on them are thick as hell, and the thermal transfer is better delidded and lap die, at least from my testing. Oh god, we got a horn. Let's get rid of the horn. Clean up the tip. And we go. Boop. Ooh. Ooh. That's a good solder joint on the other side too. I'm just gonna make sure we got a good one. Yes, it's good. That's a good. You said it's a good. I need to get more capacitors. Give me 1 second here. I haven't used this soldering tip in a while. I like the hoof style tip for basically everything. After learning how to use the hoof style tip, it's like, oh my god. It's the best. It's the best around. Haven't touched the CPU barely this season. Yeah, well, you're starting to learn. You're starting to learn the GPUs are way more fun. Hey. Oh, baby, it's so good. Oh, that's not a good joint, though. That is not a good joint. It's on, but it's not a good joint. God knows all about those good joints. Well, maybe not right now, but... Yeah, maybe I'll switch the hoof style tip, because I do like it more. Can't get a good angle. I can't get a good angle for the... Oh, that's actually a pretty good joint. Yeah, man. There's a lot to GPUs, and it's way more fun. Way more fun. Way more tinkering can be involved. I mean, I still modify my CPUs, RAM, GPUs, and motherboards, so I still have fun, but GPUs is where it's at. I mean, oh, baby. Oh, baby. I might put the hoof style tip on because this is actually a pain in the butt with this one. I even got it all pretty looking too. Look at it. Oh, look at that tip. Just look at that tip. So shiny. Next. Do as I say, not as I do. Hey, hey. Hey, that was actually pretty nice. That was actually pretty nice. Nice. Oh, yeah, definitely more points. Definitely more points. Yeah, you can't do that. Well, I mean, you can get distracted. It's fine. You'd be like, oh, I'm gonna work over here. I'm gonna work over here. I'm gonna work over here. Eventually, you'll do the whole area. Oh no, overheated it. Look at it. Look at it. It's so off now. What did I do? What did you do? I need the hoof. Yeah, I need the hoof tip. I gotta switch this. Nope. I'm not dealing with this. It's already a pain in the butt. I have ADHD. Yeah. Yeah. Yep. And I have OCD. So I gotta do things a certain way. So if you think I'm mad at you for something you said, I'm sorry. I like things a certain way, and it's gotta be true facts. It's gotta be correct. That's why I'm switching the tip over to the hoof tip. The hoof is the king. It doesn't look very pretty, but it's the king. I'll make it look pretty here in a second. Promise. I promise. No, yeah, yeah. You keep that RGB garbage away from me. Again, if you like your RGB and whatever, that's you. I'm glad you like it. Keep it the way, keep it the F away from my surroundings. I will call it your unicorn puke. You got to take that as consideration and take that as a compliment. Because I will not give an actual compliment. If your if your cable management looks like mom's spaghetti, that's a 10 out of 10, by the way. And there is a Discord channel if you want to put your PC hardware in there or have any kind of questions and whatnot. I try to help out when I can. Everyone likes to see PC hardware and all that, so. I even cleaned up my soldering tweezers. Oh man, don't they look so good now? Look at that. I don't have old flux all over them anymore. And then I have to clean up my other ones, my angled ones. So I don't use them as much, so I didn't really care to do it. Alright. Let's get rid of this thing. Um We'll just set it here until it cools down, because it's super hot. And we'll put the good one on. Get on there. Oh yeah. Come to daddy. Oh yeah. This hoof style tip is like, my god. Yeah, baby. Look at that. Now we gotta heat it up. We gotta clean it up. Get it all looking pretty. Cool down yet, or am I gonna burn myself? No, yep, I'll burn myself. I gotta wait. It's still very hot. Gotta warm it up. Gotta warm it up. Gotta warm it up. Come on. Nope. Not warm yet. Takes a hot minute. Get it? Hot. Because it's a soldering iron. Yeah, I got jokes for days. Alright. Oh my god, she's looking pretty. Oh yeah. Look at that. That looks better, eh? Found 4 gigabyte stick to 2 that is low density is still 800. CL5 800. That's pretty good. Hopefully be able to overclock at least 12. No, 14 maybe, but 12 for sure. 12 for sure. I'm gonna do a little bit of flux on top of that, and I'm gonna clean up the other ones because I'm not happy with them. Oh, $75? That's a little much, buddy. You get yourself some Kingston, should be able to get them cheaper. Oh yeah, baby. I love it. Oh yeah. Oh wait, that one's off. That's right, I gotta move it. There we go. Oh my god, it's like a mirror. Oh, should have been using a hoof style tip from the beginning. Yeah, I mean, I got mine dirt cheap. I got all the kits I have like for like $10. Unlike my DDR3 where I got the DDR3 for free. Oh no. Oh no. The only thing with the hoof style tip is I gotta hold the component more. Let it cool down more. As it superheats it. There we go. Oh. There we go. Let that sit for a second. You gotta move the heat up a bit. It's a little too much for it. A little bit of flux for it. Nugget! What's up? Clean up this side. There we go. Beautiful. We'll go back to this side. Need to hit it again. Beautiful. And these ones, I just need to do a little bit of a dab to clean those up. Beautiful. And this one, I gotta clean up the tip. And a little dab to get rid of that extra solder there. Beautiful. Yeah, the 2-dim boards suck because there's not much of a difference between the 2-dim and the 4-dim on DDR2. Like there's like no difference because of how like you don't have to worry about instability of any sort or overdoing the memory controller. A little bit more flux to this one. And come here, capacitor. Come here, you. And that's there. Hey. There we go. I have to retouch that up, but that's on there for now. Oh. Oh, Nugget. What you doing, baby girl? Anything else you'd like? Nothing? Oh, okay. Alright. Hi. Nope. Not enough. Nugget, don't hit me. No, don't hit me. It's soldering. You're like, I don't care. Pet me. Oh, that was a beautiful. And I gotta touch the other side because there we go. Too much solder. Now it looks beautiful. And before I go too far, I'm going to clean up the flowers. Make these look pretty. Which one? This one? No, this one. This one. There we go. Your hand system on 2K, but it's for yes, yeah. Even 4 GB would be better, even on like a Windows 7. 8 GB, lots. For Windows 10 though, yeah, you're gonna need 8. Even a good stripped down Windows 10. Okay, so we're gonna do yeah, I'll do these little guys and I'll work on these bigger ones. Yep. Um, better filtering. Better filtering, and you gotta think that each one of these is a battery. So it stores voltage. And then these smaller ones is better filtering. Your can caps, your bigger caps. So these are tantalum polymers. They're a large battery before your core. And they also got these ones for your core as well. Actually, no, these two are actually for memory controller voltage. It's like a battery bank, tantalum polymer, and then these ones as well, like this one and this one. And then your can caps, these ones here, are your large right around the VRM. So that way they're decoupling. which they also filter. They're a filter and decoupling capacitor. And these ones here, your smaller ones, the smaller they are for the microfarads, these are 47 microfarad caps and stacked up. And technically a smaller would be better for higher frequency, but since this card can only go so high of a frequency anyways, 47 microfarads good. For your newer cards, what would be better for them is a 22 microfarad stacked up. And since there's so many caps on the core, it'd be more beneficial than 47 microfarad caps. Also because you got way more frequency, like 3 gigahertz now. This card here, stock, is 700 megahertz. No, don't stack resistors. No, 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 no. Yeah, yeah. Keeps things. Yeah, keeps the voltage steady. And because these caps here, the microfarads will also, NLCCs and can caps are different. Tantalum polymers are also different. These smaller caps are better at studying the voltage at higher frequencies, and that's why they're around your core and memory, like these ones here. More or less for your core. That's right there. The core is right underneath that. And then your bigger ones are a bit farther away because the frequency, once you get closer to the core, matters more on the actual what component you're using. Yeah. Most time, most time, especially graphics cards from like the 1000 series and back, 47 microfarad caps is good enough. It's not like you have to worry about the frequency as much because you're not going to get such a high frequency as the newer cards. But the higher the frequency, the lower the microfarads, better. Just due to the fact frequency matters for it. Also, man, what was I just thinking here? Oh yeah, so temperature, okay? So why they'll add extra caps like this, extra MLCCs as well. If I did LN2, liquid nitrogen, or even dry ice, but more or less liquid nitrogen matters more. As soon as you go below -40, your capacitors start losing charge. So these 47 microfarad or your tantalum polymers here, that's our 227 microfarad. If you go down to -100, this cap automatically goes to a 100 microfarad. So you're losing the battery, basically. You're losing the charge that this thing can actually do. This is a 470, this is a 227. Same thing with your caps, your MLCCs. No, not in parallel. Nope. It's not that much of a resistance change. And it's not resistance, it's voltage stabilization, basically. Yes, getting ahead of the curve, yes. So, temperature matters. Temperature matters. If you don't add extra capacitors around the core, and the core will get very cold with dry ice and LN2, even chilled. My chilled loops will go down to -20 right now, because that's what I can do right now. But you're not really losing capacitance at that temperature. Below -40, that's when you really start losing capacitance. -100 C, though, is big difference. Like, you're splitting in half, basically. It's for transient spikes, not for resistance. Yeah, neg temp diff. You're not really looking at the resistance, overall resistance. Caps don't do any resistance. It's to help with transient spikes. That's why you got these big caps for decoupling from your power source. All right, so that goes into your VRM. These are VRM, decoupling for VRM. Then from there, you got more to help cut back more transient. And then here as well. This is main though. This is your main that you want to look at. Right below the chip, right below the memory. These ones. You start changing resistance, that's when voltage changes. And you don't want voltage to change. You want it to stay constant, consistent. You don't want it to fluctuate. That's where the transient spikes. And transient spikes will be on depending on what you're doing. Could be games. You got a lot of up and down, up and down, up and down. Like your heart rate on the monitor. You want a dead flat, but you'll never get a dead flat. But you want you're flatlining. That's what you want. You get close as you can for that. That's why one day I would like to be able to afford an oscilloscope to show people that kind of stuff. It's not really needed. It's just fun to show. And everybody was kung fu fighting. Whoa. Yep, the waveform. Yep. You want constant. Nice constant. Ooh, a beautiful. And that's why I like the hoof style. Because it works so good. Oh. Get out of there. Get out of there. Oh, I guess I need the tweezers for that. Come here, you little hair. Ta-da! Oh. I got one hair, but there's another one. Yeah. Bam. And then we got to do the other side, but I think before that I will add on an 0402, the little guy. And that is this one right here. Good thing I have a couple caps laid out here. Little guy. I'm not doing the 0201s. Those could be 0102s. Pretty sure they're 0201s. I'm just going to do the 0402s, which are also very small. No, it's not on there. It's nice. I'd like it on there. There we go. That's beautiful. These ones suck because you gotta be very quick because of the amount of thermal transfer can desolder it. Check the. I need some solder. Need some solder on it. Not much. Just a little something something for the something something. Beautiful. Beautiful. That is that. And it's really hard to get in between that for cleaning now, but I guess I'll modify the Q-tip a bit. There we go. There we go, there we go. blam. Alright, so that's stacked up. That's good enough for that. Flip this around. I want to do these two as well. This one and this one. Oh, and maybe I'll do this one and this one. Yes. Yes. Si, senor. Am I gonna worry about the 12-volt input from the these? I follow the trace. Oh, it could be from memory. I've never checked the voltage. I'm talking about. I know I'm just basically talking to myself right now. For these caps here, I'm not sure what they're going to, if they're memory controller voltage or core voltage. Your memory on the NVIDIA card, your memory controller voltage, so in your core memory controller voltage is the same as your memory chip voltage. They're the exact same. So if you modify your memory controller voltage or your memory voltage, you're changing your memory controller voltage in the core as well. So that's why you gotta be careful. You gotta be real careful. And everybody was kung fu fighting. Those days were fast as lightning. Oh, I need some flux. I need a little bit of flux. Ooh, beautiful. So you're feeding power to the memory from something else off the PSU, those blue connectors? No. 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 Those... Give me 1 second, I'll show you. I just want to finish this solder joint up here. Those days were fast as lightning. It was a little bit frightening. No, you're not. No, you don't want to do that. You don't want to give the graphics card any voltage from. I mean, there are some cases where you can feed it artificial voltage. There are, like, like, you ain't wrong. There is some. It's not appropriate though. It's not appropriate. It's not appropriate. It's not appropriate to do, and it can be very, very. It could blow things up. It can blow things up a lot worse than what I have set up. Okay, so let's go zoomy out. All right. So these blue things. So I have it set up here. Black wire is ground. All right. Let me just move the hot air out, because I'm using that for warming stuff up. So, because the board's warm, my hot glue is starting to go. That's why I want to get some epoxy masking. It'd be really good to have. It'd be permanent hold. It's basically a permanent hold. So, black wire ground goes to what the ground to the this is a resistor, all right? So it's a resistor like what you would find somewhere else, like that. I should have one laying around. Do I have one laying around? Oh, maybe I don't. Those feet were fast as lightning. It was a little bit frightening. Oh, I got one right here. Okay. So this is what it looks like before you put it on the board. Now, this is what it is. It's a variable resistor. Yes, resistors change voltage. Okay. This knobby knob. So if I go back to here, ground goes to ground. This is a good ground spot. It's just a grounding spot for, it's just a connection point to hold on DVI or whatever. But that's a good ground. So ground, that goes to ground. For wiper, swiper no swiping. But the wiper here, it's called the wiper, is what the actual knobby knob makes contact on the inside, like a dial, basically a dial inside, with different kind of thickness of pads for the dial, basically. And the different thicknesses will change the resistance. You change the resistance. And so this one here is right here. W204. Can anyone tell me what a W204 variable resistor is? Can anyone tell me? Ga, do you know what a W204 is? Then you also got, I got more, hold on. A W2O, focus you, W202. A W502. No. These are, the numbers are codes. You can use Google if you want. Let's see if Google can actually figure it out, though. Actually, yeah, that's a good test for AI. It's a good test for AI. Correct. I have some of those. I think of where I put them. I don't know if I put them in my case here. Capacitor and switch case. Might have it. Might have it. I don't think so, though. No. 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 I do not. So those resistors you're talking about, those color-coded resistors, are known as through-hole resistors. They still apply to today. Is that what it's saying? Is that what AI is saying? Blower motor resistor dash regulator from HVAC? You're joking. Those color bands, though, purple, yellow, or purple, yellow, orange, black, are all color coded for the resistance. So a certain resistance for how it's laid out. And I actually forgot the color chart for it. W204 resistor AI set for blower motor, it like in a car. Oh, wait. Put variable resistor W204, or what is a variable resistor 204? or what resistance is a W204 variable resistor? Sorry, that's better. That might be better, but that's wild. It's actually giving you that because these are actually fairly common. These W2, that's a W202, and these W204s are fairly common. You more or less could be using 502s and 503s. Yeah, black, blue, red, orange, yellow, green, blue, or green. Yeah. And then yeah, like there's a whole bunch like and the way the color code works too is odd, but it works. That's why I can't remember it. I haven't used it in a while. I have some of them somewhere. I'm not sure where I put them. And then you also got some of those as well, some of those resistors. You also got some of those resistors where they're one way, and a lot of people didn't know that, and they put them in one they put them backwards. Then they wonder why their component wasn't working because they're a one-way resistor. Now it's talking about Mercedes. See, that's why AI sucks. Two hundred four. Despite the name, the W204 blower resistor is actually a PWM pulse width modular transistor controller, not a resistive ladder. No fixed ohm value, no variable resistance curve, no testable continuity will appear open circuit on a multimeter. YouTube blocked it. I can't even read it. Can you allow that message through? I'm not currently set up to allow. I'd like to be able to see what he said. As long as it's not too inappropriate, I don't mind, man. Yeah, one of these, so the W really is not much of a, in my opinion, not much to look at. The 204 though. Oh, gotcha. The 204. So you got 20, and then basically you're adding on more zeros, which could be a 200,000 ohm or a 200 kilo ohm resistor. Variable resistor. And you have to match up the resistance to what you're modifying a certain way too. As in, let's say you got a resistance off of your controller, whatever your resistance is on the feedback, you got times that by like 25 or by 30 works too, but your stepping changes too, and you gotta worry about your stepping. And the stepping is you go too high of a resistance on your variable resistor, it's gonna take more turns to get down the volt or get the voltage up because you're changing the resistance to the controller. So you're tricking the controller thinking it has less resistance, which is less voltage. So the controller will up the voltage to the core or the memory. And then once you go further down this dial, the stepping, the change from a little bit of a turn to more of a turn changes. So you lightly turn the knob. So you're basically lightly turning it. You can turn it literally just a little bit. I'm trying to show a little bit. You can just turn a little bit, and that will change the voltage a lot because your stepping changes. Hopefully that makes somewhat sense. Never gave an option? Oh, okay. Yeah, AI is stupid. And then, like, let's say you wanted to change the resistance through voltage sense. Voltage sense, you cannot use a standard kilo ohm resistor. You want basically like a 50 ohm resistor. Now 20 works too. I'm using a 100 ohm. No, a 500 ohm. I'm using a 500 ohm, but I also know that my stepping, because I have to put the knob all the way down, this all the way down, the resistance all the way down, to where the stepping, I lightly turn. It takes a flathead, a tiny little turn. We're talking like a little turn will change the voltage by like 100 millivolts because the stepping is so large. That's why you want to go as close with voltage sense, close to the actual ohms that you need, and you're gonna take reading from ground to VRM, and it's not you're not timesing it by anything. Well, you can basically times it by 10, but you want to get as close to as the actual reading is as possible, and you also have to worry because the actual resistor will get hot because a lot more amperage goes into the actual variable resistor, where feedback will not give you that amperage. It's just voltage, low amperage, voltage, and actually low voltage. Uh, if I'm not making sense, if you want things explained more, let me know. I try to explain things as simply as possibly as I can because it's not that difficult. Tricking a controller is very simple once you start knowing the controller. Not all of your PWM controllers are the same. Like this NCP 5388. It's not gonna be the same as like your UP 9515. Not even close. And then you got your resistance dividers. You got your resistance going in, and then you'll also have your filtering cap, which is generally a 0.1 microfarad cap going into certain pins. So that way the steady voltage to make sure, let's say if there is a transient spike that somehow goes to the actual controller, it doesn't read and turn off the card. Or make it self overvolt somehow. There's a lot that goes involved with all this. There is. It's not as difficult as what some people make it up to be. And I've done all these mods live on all my cards. I've done them all live to show, because not all the controllers are the same. And sometimes people just need to understand the controller. Yeah, electrician is different than this kind of electronics. You're doing AC, this is DC, right? In a way, it's the same. You still got a circuit. The way your circuits are laid out and all that is a lot different. Yeah. AC, alternate, DC, direct. Yes. Yes. So that's why switching frequency from your controller or whatever else matters. Then your phases also matter. Your newer cards, this card here, all 3 phases will run. I don't have to do any mods for it, but newer cards, you got all these phases, but generally you only run in 4 phase out of your 10 phase card. You can modify it with the resistors to the controller, but is it needed? Generally not. Can it help? On higher loads, yes. So let's say you're on LN2 and you're pushing, I mean, I've pushed some of my graphics cards 600 watts and their max power before was 155. Like my AMD RX Vega 56, GTX 1080 Ti. I pushed 500 plus watts on a GTX 1080 Ti. That's nothing. That's nothing. That's actually nothing. For like a GTX 770, after fully modifying and all that, you can push it to about 1,000 watts for that one graphics card. That was stock 220 watts. You can push 1,000 watts into it. That's when things become a little bit trickier on what matters and what doesn't matter. What MOSFETs are good, or can you switch out the MOSFET to something beefier so it can handle it? Do you have enough cooling for this section of the GPU? Does your controller have enough cooling? Do you have enough filtering? Do a tiny bit of electronics in school, halfway, full wave rectifiers. Yep. Yep. Yeah. Yeah. There is a lot of... Hopefully I didn't knock anything off there. There is a lot of parts, but it's not terrible. Fixing graphics cards can be a pain in the butt. And that's why I want to invest in the voltage injection, so I can... Voltage injection is a lot easier to fix certain components, because there's thousands of capacitors, there's thousands of resistors. You know how hard it is to take a multimeter and test every single resistor or every single capacitor? Not easy. And it could literally be 10102 capacitor that's gone, that your whole card doesn't work because of it, that's shorted. Yep, he's good. I comment on some of his videos because some people are just not making sense onto him. Like, well, this is, like, he doesn't talk about, but this does this, this does this, this does this, this is what can affect this, and a lot of people will go, dang, okay, yeah, yep. How come he didn't talk about? Because it would make his already 30-minute video like 3 hours long. I'm simplifying it. Or like one of his videos, like the controller, he was like, well, why did they do this? Why is this capacitor here? And then he added in beside it, because you can add into blank spots. Yeah, exactly. Short. His short videos are like 20 minutes though, or like his short ones. And then some people are like, well, why he doesn't talk about that? Well, because of this. It's also like right here, right? Like resistors and all that. Again, this is the where I shorted out a couple pins to make sure there's no over current protection on it. This card I can blow up easily if I wanted. But yeah, there's pads. See these pads here? They're blank. You can add in a cap or a resistor and take out a resistor, and it does the exact same thing. And he's like, well, why did they do this and this? And then I added this in, and it's still doing this, because It's just bypassing that one resistor. That's it. It's just bypassing it. That's it. But how is this pin still, or how is this resistor still hit the pin if I remove this resistor? But then you remember, you added this one in. This back pin here, or this back pad, could be internally connected to this pin. Or this back pin could be connected to this resistor that's actually connected to this because of the way a controller actually works. You'd have to look deep into the data sheet to figure out that that's actually happening, and that you don't actually need to have anything on these pads to make it so this one works or this one works to that pin. Yeah, there's a lot of internal works that will go to these pins. And this whole side is voltage sense, feedback, ILIM, and another one, which these two are connected. And this is just a logic board. So all these voltages going to a logic that goes out. That's it. So this basically, well, this side will go out this way, and this side will go out this way. That's how this one works. A ton of redundancy, but that redundancy also can correlate to your overclockability. So let's say you start taking out a bunch of these capacitors, and I could take out all of these capacitors if I want, every single one. Card will still work. How is the overclockability though? Because filtering matters a lot. Redundancy's there, but the filtering is also needed, especially when you start getting into higher frequencies. Again, the higher frequency cards. Now we got the 3 gigahertz plus cards. They'll have this whole area will be filled up with capacitors, generally MLCCs. Some will have some tantalum polymers, but those cards are generally not overclocked as far, because this right here, the filtering on this is terrible. It's actually terrible. The such a high microfarad cap for high frequency is terrible for core. That's why some of those gigabyte cards with them were actually all of them were not roughly 50 megahertz or 100 megahertz less of a frequency than the ones with all capacitors. They might have that nice, it might work just fine, but it's not overclocking as far. Not because of thermals or voltage, but due to the fact it was terrible filtering. It will lower your memory OC. That's why adding on caps to your memory is good. Which I should add on these 0402s. I see these aren't even 0402s. I don't even know what these size are. I need to add more, technically, but I'm not going to. Maybe down the line I will. It already overclocks fairly decent for memory with all the mods I've done to it. Just happy with it. I'm only saying I'm happy with it because I really don't want to solder those, and I don't have enough caps to even make it worth my while, because it's 8 caps. 2, 3. It's 3. These are not 0402s. Oh, maybe these are 0402s. And the other ones are not. But it's 3 of those per memory chip. And then it's 1, 2, 3, 4, 5, 6. 6 0102s for each memory chip. Like, it just takes way too much. Yeah, the pencil mods work really good. Except if you got a crappy controller. Then you can only go up to like 20 millivolts And depending on your benchmark that you're doing, you go up that 20 millivolts and you get a transient spike. Well, there your card turned off, or it didn't pass. Didn't pass the test. It just crashed the test. Even though you're only giving it 20 millivolts. That would depend on controller. Some controllers are just an absolute pain in the ass, man. Like people get certain GPUs because the reference style PCBs generally have a controller that is more more. Am I streaming? I click streaming. Have I really been talking to myself the whole time here? Oh my god. I have been. I was literally talking to myself the whole time. I just had a conversation for like the last 3 minutes. Okay. Did you hear me talk about the controller and all that? Probably not. So I just clicked streaming again. Yeah, as soon as you go past certain voltage, transient spike hits and it's going, okay, well, even though you got like a filtering cap here, there's a filtering cap here, and these are usually either a 1 microfarad or a lot of them are 0.1 microfarad. You just got audio? Wow. Wow. Took it long enough. I crashed. The only reason why I'm crashing on some of my live streams is because I still need to either take apart the power supply, and I have to make myself. I want to make myself new CPU 12 volt power cables and GPU 12 volt power cables. I need to make some cables that are good for high wattage. But yeah, I think one of my power supplies, it could be the power supply or it could just be the cables. They're old, so I need to fix them up. And I want to make myself new cables, which I'll do live stream, of course, and show people how to go about making it. It'd be like a warning. Do not try this at home. Do not do this at home. But do it because it's fun. But I already warned you not to do it. Yeah, that costs more than they cost. Those would cost more. Plus, those are 8 gauge wires, are they not? Or are they 10? They're probably 10. I was looking at 14 gauge wire, and you get it fairly cheap. 14 gauge. Just I would like a flexible coating, right? I would like a silicone coating instead of a PVC. And I can make them nice long set of 12 volt power. What's expensive is actually the actual plugs. The plugs are expensive. And I got this. I'll be setting this up. I gotta still rip out the 2 center wires here for these 2 center. And I can use this for adding on extra power to a graphics card. But 2 center here, so we can get rid of the data line. It's a sense line basically. So you gotta get rid of that and keep the grounds and keep the 12 volt. The whole bottom row will be your 12 volt. Top row will be ground, data, sense, and ground. Then your 8 pins, your extra 8 pin is just another ground and a sense. And the sense is just to make sure when you're connecting it as well, you connect in your 8 pin, and let's say you have another 8 pin, it's so that way they can talk back, be like, oh, I'm plugged in. You plugged in? Yeah, I'm plugged in. And that's all done on GPU. And a little bit on power supply too. Yep. That's why a lot of people get certain graphics cards. Not because of the great design and all that. Not really, because they're simpler to mod. I don't care about simple. That's why I get EVGA. The EVGA is terrible to mod because they're fully custom. Generally the PCBs are all fully custom. Custom. Let's go. But custom can be a pain in the butt. I should share some pics of the 6-pin added up to a PSU. Did a shell swap on. Oh my god. Yes, I want to see. I want to see this death trap. Please. Just make sure when you put it in, say, do not try this at home. I mean, everyone there already knows not to do that kind of stuff at home, but still, you should. I need to make myself another coffee. I need a coffee. Oh, is that kitty winny pretty kitty? Oh, gotta go. You comfy laying back there? You're lucky I'm sharing my chair. Alright, I'll be back in like 2 minutes. Just give me 2 minutes. And then what I'm probably, if anyone has any questions, let me know. I mean, sometimes this is a lot to look at and take in. But it's okay. You can take it. I promise. I didn't know you, baby. Apple uses very low, no, solder. Yeah. probably like 110 degrees Celsius melting point. It's low melts generally around there. Yeah, solder. I like the solder. I like the solder. I'm Canadian. We call it solder. Yeah, playing with PSU is kind of fun. As long as you don't, touch two connection points on a capacitor, you're generally just fine. If you do touch two connection points on a capacitor, though, things can get pretty wild. So it gets real spicy real quick. Real quick. Like, oh man. Yup. Sparks will go flying. Or melt whatever you touched. I love the big old capacitors. Suda? Suda? I like the Suda. Yeah, with a hard R. Yeah, we solder. I had someone from Britain comment on my videos. Can you say solder sometime, please? I really don't like the way you say solder. But great video. It's like, thank you, thank you. I'll try to say solder sometimes for you. Say it. Say chowda. Chowda. Do I have enough water for coffee? Could do. Oh my god, I have just enough water for a coffee. Let's go. Hey, Nugget baby. What do you want? You've been sitting behind me on the chair, taking up the whole chair the whole time. What do you want? Speaking Jamaican half it. Really? That's odd. Oh, that is an odd one. Where did I put my sugar? There it is. Computer. Oh yeah? Gabby hasn't been OUT in a while. She probably wouldn't like the snow. We've had a couple of blizzards here the last few days. Now yet, go lay down. What do you want? You cute little shit. What should I do? Oh yeah, I gotta do this one right here. So, we'll do a little zoomy zoom. this one. I get rid of this hair. Go. Because I want to do that one there. Oh, and this one here. This one and this one. This one, not really much of a concern. It's David G. Fucking dumbass. Alright, get some hot air going there. There we go. Stir up my coffee. I want my coffee. Oh, I bet you did. When you went over there and got on your knees for him there, Squeeze. You just hop down, puckered up your lips like, come here, Danny G. Okay, no need. In here, I need 1. And I need 2. 2. Am I gonna worry about the third one there? I don't think it's really needed, but maybe I will. Just in case, I'll get another one out. Get another one out. The gift up. The GIF. I don't know what GIF you're talking about. We need a little bit of flux. Flux for you. Flux for you. And I'll just do that one there because maybe. Oh, gotcha. I don't have that shirt anymore. My one X made me get rid of it. Oh my God. That's a beautiful, no matter what they say. Nope, not good enough. Not good enough. I want a little bit of solder on that. Oh, I'm moving it around. That's okay. Oh, that was nice. That was nice. I'm just gonna get the other side here quick. There we go. Just to make sure. There we go. There we go. Turn this around. We can see that, right? Yes, we can. There'll do. Trying to look for it on there. When you have a second, lol, it's low qual. Where'd you put it? Yeah, YouTube blocked it. I have a Discord channel. There's no, yeah, you can't do any links, unfortunately. Back to the other side. It's not enough solder on it. Oh, now we got a little horn. Can we see the horn or no? Yeah, sort of see the horn. Look at the horn. Look at it. Easy fix, a little bit of flux, and a little bit of a loop. Gone. No more horn. And over there. And there. Yeah. I'm only pretty quick because I can use both hands. I'm not holding it very good. Oh, 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 oh. Yeah. I need to position the graphics card on my holder here a bit better. I keep leaning on it gently and it keep moving. Yeah. Yeah. And then I'm probably gonna need flux after hitting this side, but that's okay. Yep. Yeah, we got a little horn. Yeah, a little horn, but that's okay. We just a little bit of flux, and we just boop. Beautiful, beautiful. Go clean it up nice. Look at that. So beautiful. Wait, wrong team. Yeah, we have been influenced heavily by our literal brothers to the south. That's good. Yeah, I think we are more like Aussies than anything. No, like it. Yeah. Yeah, I agree on that one. I'm not too happy with that. I just looked at the screen there. Yeah, I don't know if you see it, but I see it. Here's some flux. Here's some flux. It shifted again. I knew I should have held it. There we go. Oh yeah. That's a beautiful. That's so beautiful. Hiya, hiya. Well, thank you. Yeah, I like to make sure that it looks nice and pretty. I think it looks pretty good there. Except for that one joint too. It's got a little bit of a bubble. I don't like it. I don't know if you can see it. Can we see it on camera? A little bit of a bubble. Yeah, you can see it. A little bit of a bubble. Not much. Doesn't really help with voltage, just stabilizing the voltage, filtering it. But yeah, you gotta think these are like little batteries too. Capacitors, whether or not these or the bigger ones, they're basically little batteries. They do a little bit different jobs depending on what kind of capacitor you use, but they basically do the same thing. Same thing, but not the same thing. These don't do decoupling, these do more filtering, noise, transient spikes, voltage stabilization than anything. Help stabilize voltage, give a stabler voltage, and stacking them like this gives a bigger battery bank that stabilizes the voltage, that filters the voltage, so that the core hits a load or whatnot, it has more battery to drain, and hopefully you'll never run out of drain. So we're gonna add a little bit of flux to this one, and we're gonna clean this one up from the little bit of not much of a bubble, but there is a bubble there, and I'm not too happy with it. That was one I did before. I'm just noticing it now, apparently. There we go. Clean up the tip, go to the other side. Should be able to just, oop, yeah, there we go. There we go. No more bubble. Let's go. Yay. And just look at that. Although this one too has a little bit of a bubble. So a little bit of flux. Clean the soldering tip. We'll just grab that bit of solder. Oop, like that. Done. Oh, too much fluff. Need a new Q-tip. I need a new Q-tip. Clean this up. And then heat up my toothbrush. There we go. A lot of the hairs. Kissy little boop. I want to get some of this flux from in between, which is a real pain when you start stacking it, because the Q-tip never wants to fit where in there. It's a real pain. There we go. There we go. Not better. Dave. Where's Dave? Where did I put Dave? Oh, Dave. That's right. I knocked Dave over. I haven't picked him up. He's probably not happy though. Give me 1 second. I'll get Dave. Oh, Dave. There he is. I found him. There he is. We got Dave. We got Dave. He's not happy. He's not happy. Give me 1 second. I gotta unzoom. Dave. Not happy. Poor Dave. He is not happy. Okay, so the core is done now. The core is done. It's got caps on everything that I want to do. I could add on a couple of 0102s. Those are fun. Those are... Even professionals don't like to do those. Give me 1 second, I'm gonna even drop. Oh yeah, we'll have to drop this down further. And then... Oh. Did I crash? Am I still here? Okay, so what? My camera app is not liking me. Oh, I accidentally clicked it. Oh, whoops. What did I do? I figured it out. I figured it out. Can we see that somewhat okay, guys? Is that all right, or do I have to go zoom in even further? God, see all. You can see all the Q-tip pubes. So many Q-tip pubes. Oh my God. God, there's so many. I need better Q-tips. Actually, better flux would actually help with this. You can see, there's so many Q-tip pubes. Okay, let's get into the fun soldering. So let's do. What one can we see very well first? Don't worry about. Actually, what I'm gonna have to do. Switch out my soldering tip. 1 second as we cool down the soldering iron so that way I can do the little guys. And this is what we're dealing with. I said this. I said this. Get off. That is what we're dealing with. That's right there. A wee little guy. Where'd it go? Where'd it go? Did it seriously fall down the... Where'd it go? Yeah, Nugget. Yeah, you better not be bugging me like that. You, not a little movement, and I will be messing up the solder joint if you do something like that, Nugget. Okay, we got more of them. We got more. We got more. Oh wait, that's a resistor. That's a resistor. Yes, Gabby, stop it. It keeps pushing on my arm. Where'd it go? There it is. Nugget! Stop! There. That's a resistor. We do not want one of those because that will cause a short. We don't want a short. I don't have any isopropyl. And the only brush I have is this toothbrush that's already getting worn out. Yeah, it is a very small capacitor. And these are generally 0.1 microfarad caps. Good for high frequencies. No real capacitance. Strictly for filtering. Oh! Where'd the other one go? Did it go down the hole too? Oh no. I don't know. I can't even see it on screen. It's small. No, it fell off my finger. That's why I'm looking underneath. I think it did fall underneath. I just can't see it. It didn't fall anywhere here, else I would be able to see it. Nothing else. Yeah, no, none of those are loose. Those were all there before. Yeah, they're strictly filtering caps. So soldering iron cool enough yet? Almost cool enough. We'll grab this one. Oh, come on. I gotta clean. As soon as the soldering iron's good to go, I'll clean the... Hey, God, where'd it go? Oh, there it is. In the hole, in the hole. Yes, so I'll be doing those ones. But I got... Hopefully it's cool enough. Almost cool enough. Almost cool enough. While we wait, I'm gonna drink my coffee before it gets cold. You need to like go lay down. Thank you. I cannot have you hit my arm while I'm doing this. One little movement and it'd be no good. Alright, cool enough. I can switch over the tip. Let's go. Still hot. Go quick though. Go quick so it doesn't melt my hand. Ow. That's hot. It's hot. Blah. Nope. Well, hey, come here. Set it there for a minute. There we go. And we need a little soldering tip. We just need a whittle one. We just want a whittle one. Bam. Yeah. Yeah. She's broken a graphics card on me, my GTX 770. I just don't want her around when I'm doing this kind of stuff, because just in case, even though she doesn't go up on tables and stuff, I still don't want her to be around, just in case. Little soldering tip. Yeah, wait for it to heat up, though, so I can clean it up. Alright. Alright, so which ones we're gonna do? We're gonna do that one. So let's move this. Like that. And hopefully you can see that all right. We're gonna need a minuscule amount of flux. So let me grab this. There we go. Oh, that's right. I gotta clean up my soldering tips here. Yep. So what I do with the soldering tips, like if they start holding on and getting sticky, good way to do it to burn it off is just like that. And it'll burn off any of the flux. And then you should be able to just boop, drop it. Yeah, those are pretty good joints. I'm actually quite happy with that. It needs a little bit of flux though. Got a little bit of a horn on this side. We just need to do that. And a little boop. And we can clean it up. The smaller ones still grab the Q-tips, but you'll know when it has horns if it's really grabbing. You don't want the horns. Voila. One of the worst size micro soldering that you can do. Like that. Like so. So let's do one beside it. Hopefully you can see that all right. There. Oh, you can't see it. It's right behind. Well, okay, I won't do that one then. I'll do... Which one can you see? You can see that one. Yes, you can see this one. And we need a little bit of flux. That's a good joint. I'll take that. Yeah, I just use my eyeballs. I'm not even looking at the screen. I try to use a screen, but I'm like, where am I? Where? Oh, did I go this way? This way? This way? It's a little off. Can we heat it up enough so I can move it? Not really. It's a little off. Not too happy about it. Yeah, it's a little off. I don't like it. I don't like it. Now you no! Down! Down! Don't you yell at me. Okay, that's where it stays then. I don't know if I can get this one. Oh, I can. Oh, okay, I can. All right, we got it. Actually, we can do it. We can do it. We can do it. We got it. We got it. Yeah, we got it. We did it. We did it. We did it. Yay. Oh, not holding it. Nice. Okay. Now we're gonna need a little bit more flux on it. And clean up the tips. Okay. Yes! Need a little bit of solder though. Solder for that one side. Oh yeah. Booyah! That looks better. Am I happy with that? No, I haven't checked Discord yet. Give me one sec. I'm a looking. I'm looking. That little thing's 400 watt, wow. Huh. Pretty crazy that's 400 watt. That little thing. Alright, now I want to do down this row for sure. And not these ones. These won't really matter, but these ones outside will. Oh, I don't have many resistors for that. I don't know if I can, or not resistors. I don't know if I can do all of those capacitors. That might be a little much. Might be a little much. Come here. Thank you. No, Nugget. Go lay down. Go behave. Yes, hi. I see you. Roblox game crash your PC maxing out your RAM? What? It won't crash your PC from maxing out your RAM. Generally, no game will. I'm pretty sure no game will fully utilize and full load your RAM to where it crashes. Especially where yours is at right now. Yours isn't even reaching 3200. It's at 2993 or something. If I remember correctly. It's not even maxed out for frequency. It's not even at its stock rating. I'm trying to figure out which ones I want to do right away. That one done too. Pretty sure I want to do this whole row, but I don't think I have enough filtering caps for that. So here's one. There's two. There's three. Oh man, I need a lot. So maybe I should just do that one. Oh, I gotta do this one. I gotta do that one still. Nah, just because you're maxing out the capacity, that's just the utilization. To utilize and put full load on all of your RAM is it's not gonna happen. It won't happen. I just don't know any kind of game or any kind of instance where you'll put full load and full utilization on your RAM. You ain't going after any world record, Squeeze. Your 10700T is not going to do any world records. No, you cannot do any world records with a 10700T. Do you know what a world record... Squeeze, do not argue with me. Do not get me started today. You can do maybe a record. You will not even get close to a world record with a 10700T or even 3200 megatransfer per second RAM. And yours isn't even at 3200 megatransfer per second. You're at 2993 or 2997. I'm pretty sure you're at 2993 right now, from what I remember. You will not be getting a record. I would love that you could. I would. But you won't. I don't care about RAM amount. I'm trying to let you know it's impossible for a game to fully utilize and fully put on a full load of RAM. That would cause the crashing. And since you're not even overclocked to your max, to your rated spec, it's probably your CPU. That's the only thing I'm thinking. It could be your CPU. Although, what GPU do you have in the system right now? It could be your GPU. It's not, it cannot, it will definitely not be a RAM. Not unless you did something to the RAM and you've messed it up. Which that's a possibility. Knowing you, that's a possibility. Yeah, the unstable 1060. So because you are maybe using more RAM in that and more CPU power and maybe pushing more frames, or at certain parts you're getting some bad transient spikes and it's crashing your 1060. Yeah, yeah, yeah. That sounds like more of the case there. Squeeze is your 1060. I don't I guarantee it's not your RAM. Yeah, more. Uh, hold on. Where's my RAM? Where's my CPUs actually? One second. One second. Down. No. Swim babalish chadabash. Oh, it's over here. Ah, 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 ah. Did somebody say more capacitors on RAM? Then you can't see it. I got some high grade capacitors because of the heatsink covering it, but I got high grade capacitors on there too. I mean, like, like the amount of money that's on capacitors for this thing is worth more than this RAM stick. I'm trying to find my CPUs that have extra capacitors too. Old CPUs actually adding capacitors does help. I don't know where I put them. I'm looking. I don't know where I put them. They're in some drawer, I think. Nope. What did it? Yeah, capacitors help. Capacitors help. And depending on what you're putting on, it does help. Older CPUs, it helps a lot. Older RAM helps a lot. Have not tested it on newer RAM. I don't think there's gonna be much gains, if any, on new RAM. Older RAM, yeah, it works. Older CPUs work. Wait, this is it? Nope. Man, where did I put? Where did I put it? Any chance a person could develop a widget that has added capacitor that would plug and play it? Like the whole, nah, because you're losing like response time there if you're doing that kind of stuff. Oh yeah, yeah, I definitely get that. Just like how people are doing like the DDR4 to DDR5 or the DDR5 to DDR4, it's just terrible. Terrible. Would it work? Yes. Stability? Terrible. Especially going from DDR4 to DDR5, that's horrible. Yeah, bottlenecks are real. Yeah, but that doesn't do as much as you would think. The main one for the motherboards are can caps. The can caps. You're gonna want can caps for the VRM. Um, the main ones that more beneficial is adding caps to the CPUs on older ones. On the newer CPUs, they already got tons of caps on them. So maybe if you added a cap onto every single uh, existing capacitor, like every single MLCC, then yeah, that could be beneficial. It's just no one's taking the time to do it because there's very little gains probably to be had. But to the back of the core on the motherboard, I've tested it and it doesn't do anything. At least from what I've tested, even on older hardware. Same thing with like adding these tantalum polymer caps here. You can add on to them for a slightly bigger battery bank, but is it really gonna be beneficial? Not really. Now onto the existing pads. So these were not occupied. These were not occupied at one point. These are blank. So adding on to existing pads that are just there, adding on to it is automatic gains basically. Is it much gains? Not really. The main gains are these guys, but any little extra is gonna help in a way. In a way. Yeah. So when I had a 1070, I don't have it anymore. I want to get another one. It's a yeah, water cooling for sure. The main one that works really good too for the 1070 without doing any other kind of mods is just a no power limit mod and then putting on water. I was able to do 2.2 gigahertz with just no power limit mod and putting on water. Like gaming 2.2 gigahertz. It was crazy although I had the EVGA for the no EVGA yeah EVGA for the win model um, on water block. The 1070 Ti is not faster than the 1080. You could probably get the frequency higher up than a 1080, but not the per per core performance or the it won't be. It's impossible. Probably because that game's stupid, like I've said many times. Okay, so I want to do this one and this one, and I want to grab this. Hey, hey, come there. So I'm gonna do those ones. Just give me a minute here. But yeah, 1070 is amazing. Plus, I have videos out there showing how to do no power limit mods. I don't do the shunt mod, piggyback shunt mod. On I do piggyback on capacitors for the power IC, which is it's an 80p. It should be an 80p for that. On all 10 series or 1000 series, I call them 10, but all 1000 series, they're 80p power ICs, which is just reads the amperage more or less. So it'll read 12 volts, but then when you do the 12 volt, but then when you add on a 2R2 which is a 2.2 ohm resistor on top of the capacitor that goes to that controller, it reads a lower amperage. Volts and amp. And it won't go into limp mode with a 2R2. And they're so much easier to solder. Yeah, they're smaller to solder, but they're a lot easier than the shunts. The shunts are big. You need a lot of heat, and when you start needing a lot more heat, you can mess things up when you start adding a lot of heat. You don't want that. You want to make sure you do a quick job. And a quick job is a small soldering. And the 2R2 I should have, yeah, right here. Is this size? Nope. It's this size. Nope. There we go. So it's not terrible. It's easily you're able to hold it easily. And then set down on top of a capacitor, which it will be one of these ones, this size. And then you just piggyback on the cap that goes to the ADP controller. And that's how I like to do it. It's the OCPC style. I don't like to do the piggyback on shunts. Shunts are huge. Alright, baby. Give me 1 sec. No, hold me down. Alright, I'm back. How's it going, Jason? Hard part about old eyes need readers for up close. I don't need anything for looking at my monitor. Yeah. Yeah, doing these smaller ones, like these small ones here, these like 0402s are not terrible. The really small ones, yeah. Like 0102s or 0201s, 01005s, those are even worse, apparently. I haven't even seen them. These are capacitors. In one sec, I'll zoom out. They're MLCC capacitors. MLCC is multi-layered ceramic capacitors. So these capacitors are ceramic and metal layers that hold charge, and it'll help filtering for voltage. Yeah. This is the GTX 460. I just reflowed the memory chips. Again because I was having some artifacting, overclocking them. And I think it's because when I put it back on the air cooler, I pushed on the back of the core too hard and it flexed the PCB. So I reflowed the memory chips again. So that probably guaranteed fixed it. Everything's working. The MOSFET that I added on, that I replaced. It's good. Everything's good. Yeah. Definitely join the Discord. Definitely join it. Lots of people on it. We all post pictures of stuff. I try to help out as much as I can. God will help you out wherever he can as well. what kind of can are you talking about? You talking about like a mag of some sort? A can style mag? Oh, suppressors. Oh. Yeah, they got some cool. Actually, I saw some cool suppressors. Yeah, suppressor silencers for. I think it was for Sig. It's like a brake suppressor silencer all in one. Oh yeah, there's always a lot of bills they gotta worry about. We're really gonna pass this time. There's usually always a workaround for a lot of them though, but a lot of stupidity in my opinion. Okay, so we want to zoom back in here. Hopefully you can see that all right. Little bit of flux. Boop. Got one of these capacitors. Damn. I need some solder on my tip. Hey. Oh. Let's go. That's actually a good joint. That was good. That was good. I like it. I like it a lot. That was nice and clean, actually. That was nice and clean. Good joint. And very good joint. I'm happy with that. Oh, yeah. Okay, so now we got to work on these ones over here. I wanted to do at least these ones. There. Oh, these ones. So I'll do this, 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 and that. And if I had some more capacitors up there, did I knock them off? Where'd they go? Oh no, I lost them. Alright, take her easy there, Jason. They're in the States. They're in the States, squeeze. I need a little bit of flux. This one here. Clean up the soldering tip. Get a little bit of solder on her. Down there, donkey. Wait, can you see? Oh, you can see. Okay, good. Let's say, praise me. Praise me for my amazing soldering skills, because you know I'm so good at it. Now it needs a little bit more. No, it needs a little bit more love. There we go. Oh, yeah. I'm just going to hit the other side again just to make sure I got a good solid joint on that. That side's good. Only the other side's good, so I'm going to add a little bit of flux. A little bit of flux. I'm going to add a little bit more solder to the tip because I don't think I got enough for it. That's a beautiful. Make your own PCB. Making PCBs is not exactly an easy thing to do. It'd be cool if you could, but I mean, definitely not an easy task. Good off the tip, please. There we go. A little bit of flux. Yep, that's true. Well, a filter can be. Silencers on 22s are actually pretty funny. They sound like an air gun. They're so quiet. Good joint, but doesn't look very pretty. There we go. Let's hit the other side here. There we go. It's a little off too. Oh no. It is. Can I heat it up enough to move it? Probably not. It's okay, I can lift it. Doesn't look like it's on there good, but it is actually on there really good. On the camera, it doesn't look like it's on there good. It is, I swear. Need some solder. Need some solder on the tip. I mean, you can probably barely see any solder on there, but you don't need much for doing these little guys. That's a good joint. And the other side's a good joint too. I like it. I like it a lot. Doesn't look like it's on there good, but it is. I swear. It is. It's on there really nice. Just doesn't look it. It doesn't look it. It is, though. I promise. Alright, let's see. I should have a few more. I should have a few more caps. I do. In a little bit of flux. Clean up the soldering tip. Hey, it's nice. Man, that was quick and that was nice. Let's go. I need a little bit of solder. There you go. Not where I want you. Thank you. I have to take a break. My eyeballs are going, I don't know. I don't see very well. Never mind. They see just fine, apparently. It's on there nice. Yeah, looks good. Looks good. I'll take it. I'll take it. I'll just fluff. Alright. Get that back into place. Get this back into place. And no, I won't be showing this working during the stream, but probably will post it in the Discord channel of it working or not working. It will be working. I'm just hoping, I'm really hoping to redoing the memory chips, reflowing them, fixed it up for the artifacting when overclocking. I'm pretty sure it will. I don't really have many capacitors left, if any, for the small ones. Hmm. Got some old flux there too. There we go. I'm trying to think of what else I could put on to it to help. What else could work? Also, I should clean that up a bit. What else? Oh, it goes back. Okay, now what I'm gonna do is test for resistance. Make sure there's no shorts. So am I zoomed out all the way? No. Move this over there. That there. Get rid of the thermal probe. We're done with the thermal probe. Grab my well, that's not good. Ah, I found it. One of my caps. I found one of my caps. Okay, so I lost two of them that I know of, so another one ended up there. Good, 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 good. Okay, now we shouldn't have a short there. Nope, we still have a short. Okay, I'm gonna use a camera. Zoom in and look at the core here. Alright, do we see anything? Yeah, you can go in even further here. Give me one sec. Yeah, a lot of fluff, but the fluff isn't a big deal. Oh, there's one cap. One cap is off a bit. You see, I am missing the cap still. That might have flown somewhere. Let's go in more and then try to look down more here. I don't see anything in particular, so I don't see anything in particular. Okay, let's see if we're still getting that short. Nope. Yep. Nope. Okay, so what is... It looks like we switched sides on the short. So it seems to be this one. Getting a short. This one's fine now. So where could there be an issue? Really don't see any issues. Don't see any shorts. Alright, what else is shorted then? That one, that one, that one. Okay, well, that's probably just due to the fact it's the core. So if I go here, yeah, yeah, okay. Here though, here, yeah, yeah. I guess I'm not showing. Guess I should be showing this stuff too. Hopefully you can see that all right. So you can hear the beep. Now, any ground spot technically works. That's not supposed to beep. I'm showing low ohms, so short. That's supposed to beep because this is not supposed to beep. Core, one side, other side doesn't. Perfect. So we will check the okay. Good. 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 So why is that one causing a short? Nothing else is though, which is good. And the board is still warm, but that shouldn't be an issue. Yeah, low ohms. And the cap is reading short there. Low ohms. Why is it? Oh, the low ohms is probably due to the fact it's from that one cap or MOSFET that I replaced. So if I do ground, select, beep beep, and I'll switch hands here so that way you guys can see. This one here should be low ohms. Okay, well, I guess I'll switch that back. It's not even picking it up. It should read low ohms. No, not low ohms. 47.21. Good. 37. Yeah, this one reads a little bit different, which is fine. So should read pretty high. Yeah, 298 should read around 300-ish. If I held on to it, should read around 300 ohm, which is fine. And then the other side should also read that. Yep, 300. Yep, no problem. Okay, so not a short then, it's just core for some reason. Just reading low ohm. Just reading low ohm for some reason. Low ohm. Let's go off of memory. $80 ohm, 81, that's fine. Core. Oh, core. Low ohm. We're bouncing all over the place. Probably because the flux is not. That's why I need to get some ISO profile. The flux is probably not helping. And this should be power side here. Should be higher ohm. Yep. Alright, yeah. It's not an issue. Unless it's doing low ohm, but it's not short. It's not a short. Well, it's reading short. But it could just be core. This is memory voltage. This one should be memory as well. This is straight core. This is core. Yeah, it's just come from the core. Not a big deal. Memory won't do it. Yep. Just reading from the core. Nice. Nice. A little shavy shave. Yeah, even not doing it. I don't see any shorts anywhere. That could potentially be it. Everything looks alright. Did find that one cap. I didn't find the other cap though. So maybe I should look for that other cap and just to make sure. Let's check over the board. Let's check over the board quickly, make sure it's all good. Looks like it is. Looks good. Nothing underneath the mem chips here that I see. It's all good. Oh, wait. Is this? Move that. Move that out of the way. No, still reading low ohm because of that is still reading low ohm. Which I thought that would have been maybe the issue. It touching ground because we got ground there, touching ground, but it's only touching ground. Shouldn't do anything. One way to find out, it could just power it on quickly here. I do remember reading low ohms before anyways. It's not like it's a big deal. It could be reading from core for some reason. I don't have anything. I don't have like a crazy expensive low ohm tester for it to make sure. It looks good though. Hmm. Yeah, I could just power it on and see. Give me a sec here. I got a power supply that won't even turn on if I have a short. So give me one sec. Nope. Good to go. Yep, that's what I thought. We're good. No short. Just reading low ohms, because probably from the core. Just reading low ohms. We good. We good. We are fantastic. I look dumb trying to. Nah, I mean, so do I in a way, but some people say I look good. I've had some people say, nah, cut it. You look better without it. I had a lot of people say, oh, you look fine with it. I mean, you look great with it. Please don't cut it. Yeah, no, I just tested it on motherboard and power supply. Good. Core gets hot too. No faults whatsoever from testing there. Just reading low ohms, which, yeah, happens. Core does that. I don't have a $1,000, or well, more or less like a 600 to 1,000, more or less around $1,000 Canadian, $1,000 freaking tester that will make it so that way the core is not an issue. Super low ohm resistor, not multimeter, sorry, super low ohm multimeter. Very special. Not something I would need technically. something that helps if you're trying to diagnose some stuff, but not a big deal. Let's go! Alright, so yeah, good. And I will be testing it later on after the stream to make sure I can overclock without any artifacting. At least 2100 megahertz, so that way. That way I know for sure that the reflow worked. And I'm hoping I won't know how well the extra capacitors do until. Oh, well, I mean, man, I should see if I can modify the air cooler. I want to see how far I can push it on air, on the stock air cooler. Just I can't do extra voltage because the air cooler sucks. I don't think I have another. Oh, maybe. Oh, wait. No. No. No, little thing. Dude, I wondered. Do you think it would fit on the GTX 770 air cooler? Oh my god, it'll be freaking sweet if it could. Give me 1 second, I gotta clean it up. Clean it up. It's been sitting on a lot of cat hair. Oh my god, Gabby. I mean, it could be worse, but I mean, already still a lot. Need to find my good brushes. Do you think? Do you think maybe? Maybe? The GTX 770 cooler? Maybe? No, definitely not. Well, 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 no. I'd have to do a lot of work to get that working. No. What about the GTX 260? Because it's technically a better cooler on it. GTX 260. No, Nugget, stop. What about the GTX 260? That's the 1080. That's the 9600. That'll be worse. Where's the GTX 260 cooler? Where? Oh, there it is. I knew I had it there. No, it wouldn't work either. No. There's a GTX 260. The GTX 260 cooler is actually pretty beefy. Nah, it won't work either. Nah. Dang. 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 That would have been sweet. It's a big cooler and the fan actually moves on it. I could put it on the water block, but I got the GTX 2080 Super or RTX 2080 Super on it right now for the stream and all that. Ah, man. No, Nugget. Not even the 1080 or 1080 Ti cooler could work. They're not cutouts, and I'm not modifying the coolers because I want to use the coolers again on the 1080 and 1080 Ti. That sucked. No, I won't be able to. Won't be able to. That's okay. That's okay. It is ready to rock though. I just don't know what else I could do to help it. There's a few more caps I could put on. Larger caps, the 0608s, which would... they wouldn't really matter though. They wouldn't really matter. Not those ones at least. I'm thinking. Oh, I do need to find the voltage sense on the controller. And then find the resistor so I can attach that voltage regulator, the variable resistor again, the potentiometer. It's just, this cooler sucks. I can't get good contact. Like, do I lap it? No, I don't really want to. Decisions. Then it also doesn't cool. It doesn't cool the VRM. Only the air. So to cool the VRM, only a little bit of air from this blower hits it, and it's not good. It's not much. And whatever extra goes through here and through there, all through here, which is terrible. It's just terrible. They really didn't care about the VRM because they weren't pushing much power through it. Me though, that's a different story. It's a whole lot different. Thinking, what would maybe I should work on a heatsink for that. I do have some aluminum plates I could make another custom heatsink, although the capacitors are below it. The capacitors are actually below, so any of these capacitors are actually below the MOSFETs, so I don't have to really worry about them. So basically I just need to cut it to this width here. Try not to hit those. Basically the width of this. Basically the width of these tweezers. I should grab a measuring tape and get some measurements for that. I don't have calipers, so measuring tape. Maybe I'll get my metric. Yeah, either or, don't really matter. That way I can get the appropriate width and length, at least for up to certain points, because I'll be making it so that way I can hold it through the through holes. Thanks, Z. How's it going, Z? AMD for life. How's it going, man? I just don't know. Or should I wait for the wait for the cooling for the MOSFETs until I can just order some cheap heat sinks that I can just stick on, which would also be, they work and probably would be more adequate, to be honest. Because then I can also get some for the chokes, which would be beneficial, and I can also do the memory. Yeah. This card is gonna chooch when I get it chilled. Chooch. It's gonna fly. So many mods, so much extra capacitors now in the core, which should actually help benefit it. Oh yeah, I gotta search up the data sheet for this controller for the voltage sense. I just forgot what resistor. I'm pretty sure it's the second one in from there that I gotta do, and then I gotta do some testing, multimeter, and check to see and make sure it's right. How's it going, Z? I just threw it on the motherboard and that, and it's all good. Just need to finalize what I want to do to it before I get it all set up. Like I said, cooling for the VRM, more or less the MOSFETs, especially since this is only a 40 amp and the other ones are 58.2. They're 58 amp versus the 40, which isn't the worst. They're the same voltage rating, 30 volt, just 30 volt 40 amp versus 30 volt almost 60 amp, which big difference in those, since everything else is the same. So I'm wondering. I'm thinking. Not sure what else I can really do. It's gonna be beneficial for this. I don't think anything. Plus, I also have to get a mini HDMI so I can run a certain benchmark. Through DVI, it doesn't work proper. I can't actually run the benchmark, which is Unigine Heaven. Just doesn't work. Won't go in the full screen mode for some reason. I don't think I can lock all three phase. Or it's already locked. I'll have to check the data sheet again. See what the controller says. And then check the resistors to see if the resistors are correct for that. As in whether or not it is all three phase or it's two phase. It depends on load. Whether or not it's on idle, I'll use one phase, or if it's on full load, it uses two phases or three phases. I don't know. We'll have to see what it's actually doing. Pretty sure it uses all three phase on load, single phase on idle. It's been a while since I checked the data sheet for it. Last year, before September, I remember a lot on it, just not the actual phase count. Decisions. EVGA. Z needs to get some EVGA. He needs to get a bunch of EVGA. Long live EVGA. Long live EVGA. Long live EVGA. I got a bunch of them. Is it at least a supernova or is it a the G5? Oh, is it? Okay. What is it though? Is it a G5 or is it a supernova? The supernova 850s they're nice. The G5s are pretty good too. They are pretty good. I like them because they're over current protection and like whether or not your GPU or motherboard or something has a short, like it turns off your system so quick. Like it's so good. Is it do you know if it's a bronze or could be a bronze? Which again, it's fine. Now I like the EVGA because they're so good for protecting your PC. Something goes, could be anything on your GPU or something like a capacitor just shorting out, just going. It saves your hardware, man. That's why I really like them. Gold, man, it's even better rating at least. Could be a supernova then. It could be a supernova. But yeah, that's why I try to tell people certain power supplies too, especially when you're doing this kind of stuff. Platinum. So that's the efficiency rating, right? Like you can run it all the way up to 90%, 85, 90%. It'll still running really efficient, which is good. You don't want to run it that far, in my opinion, but you can. I just like to recommend certain power supplies, especially if you're doing this kind of stuff, because you can troubleshoot with a power supply. Yeah, which isn't half bad. I'm pretty sure I searched that one up before and it was pretty good. It was a B plus rating, I believe it was. You can't complain about a B plus rating. You really can't. That's almost an A. Just not sure. What are these ones? These ground? Oh, on. Okay, so that's plus. So was that? Power. 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 Huh? Oh, hold on. Power. Please. That's all both power. Why? Oh, is that supposed to be a fuse? That's supposed to be a fuse in there? L5. No. That'll be a resistor. There's supposed to be a shunt there? That might be a shunt. It's pretty high dollar. Yeah, I mean, again, you can't complain about a B plus rating. The main thing is, in my opinion, on power supplies is its overcurrent capabilities. I gotta plug it in and test these for voltage. This is 12 volt and this is 12 volt. That's probably shunt. No, it wouldn't be shunt. No. This R would be resistor or a shunt. No, it could be a shunt. Could be a pass through. It could be. No, that'd be yeah, I don't know. It should be no. What's L again? Think. Use that brain. Because a shunt should be R as a resistor, because it's just a pass-through resistor. LB. 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 What is LB? Is LB a trans? No, I wouldn't be a transistor. Oh. Oh, it's a Asus GTX 1070. Nice. I have a Asus GTX 1080. I think I got a couple records on it still. I'm thinking. Ferrite. Wouldn't be an inductor. No, no, there's no way it'd be an inductor. Ferrite, ferrite bead though. That sounds correct. No, if we check capacitance, give us a capacitance on this. I think so. No. So it's gotta be. They wouldn't make an inductor on that, would they? Wouldn't be an inductor. It's gotta be a filter of some sort. AMD for life! Capacitor should read. Hello, Nugget. Thank you for bouncing my arms. Thank you. You're so helpful. Alright. That's definitely good. Right, just give me a second here. Yeah, I've been using it. The new meter. Yep, yep, yep. That's why I've been doing a lot of more modifications. I wish I could still find the diode. I just can't. I can't find the proper diode for it. I could try to order a bunch of different ones, but that just costs too much. When the part literally costs $3. So I would like to have two working multimeters because I could check um, voltages on core and memory while I'm doing the overclocking. It'd be nice to have. At least in my opinion, it would be nice to have. She was in the moment pick for the what? Sure. I could I could put it together here and see how it works with the air cooler. Hmm. I wonder if copper shims would work technically. I don't know if I even have enough for it. Just trying to pry up the IHS here. Ugh. Come on. There you go. There's the IHS for it. Just give it a little clean. IHS for the Fermi cards. Fermi cards and 200 series also. Focus. There you go. NVIDIA GF 104. There's no way I can modify it to fit onto that to hold. So I take that off. If I take off this mount here, no, because then it's just there. Right? Like any of those line up? No. None of those line up. I'm thinking. How can I make this work? Maybe I will plug it in as well. I'll just get it set up. One sec here. Take me a hot minute to get this set up and then plugged in, and then get the video capture card set up. You retracted the message. To say, what are you talking about there, bud? Gonna say, yeah. That's fine, that's fine. A chat is a chat. Okay, so what I might also do is clean this up a bit. Just clean this up a bit here. Sandpaper's a little worse for wear, but it'll work. It's working, it's working. Okay. So we got that. Now let's clean up the thermal paste to clean it all up nicely here. And like so. And I'm going to try to fit it to this, but yes, a little bit of thermal paste. So I want to see what kind of spread we're looking at. I really like a good spread. Terrible contact. Terrible, terrible, terrible. So I have to sand it down some more. Sand it down some more here. And what I'm going to do is go grab some better sandpaper for that. Go. Just a heavier grit sandpaper, generally used for sander, but it'll do. Wish I had like a suction cup I can suction to it, but I don't. Actually, if I looked in one of my totes, I probably do for. Probably do actually somewhere. Ooh, actually, I got an idea. I got an idea! If this works, I'll be amazed. Alright. Well. Try this again. Alright, so this works. A little bit of electrical tape sticking to the top. It doesn't have to be perfect by any means, what I'm doing here. Let's see what kind of contact we got now. Ooh. Still not great. Still not great. So if I can just make better contact, it'd be a lot better. I'm not sure how far I'm gonna have to sand this down. It's definitely better, just not great. Probably better than nothing like that, so we'll do that. So I'm gonna have to thermal paste to this. And you can't be shy with that. I love these old cards because you cannot be shy with the thermal paste for these, unfortunately. Just gotta make sure this IHS is good and clean. Any oils or anything from my hand. Well, the best case scenario, it's not the greatest contact for this IHS to the core. I mean, it's better than factory technically, but still not great. I'll get this set up on the video capture device and show you what we're working with. So we're gonna need this plugged into here. This needs to goes up. That, and then I need to set it up on something like this. If not, if I don't set it up on something here, the IO will catch. Okay, move those. Make sure that's in there for now. grab the screws. These are the ones for that. This one. These ones work for it. Yep. Go. Now, GTX 1070 I have continuing across small barrel caps. Is it the VRMs I have pics? Oh, do you have pics? Yep. Give me 1 sec here, bud. And I'll take a look. Okay. No, those VRMs there that you're looking at, those 1, 2, 3, 4, 5, 6 VRMs, those 6 VRMs is for your core. That one up top, all the way with the 3 stack of capacitors, is for your memory. And as you look, you got standard Dr. MOSFETs on your memory, which is 2 high side, 2 low side. And your 6 VRM, your 6-phase VRM, has their IC controlled MOSFET, Dr. MOSFETs. So basically they're like a controller like this, but they also work for your VRM. Now, you want those to be, so to have, are you talking about, is it going beep beep to you? Because these are they're close to the core can mess up. Is it reading, what ohms is it reading? If it's reading more than what, so you're going to take your multimeter, whatever you have, continuing, okay, well, actually, put it to just resistance, auto's fine, just put the auto or whatever it has, and then hold your, well, no, you should be reading like some sort of ohms, even like top of the line, best of the best, you're not reading proper then, technically. So you're doing this, you're either holding it to one of the screw holes, so even the screw here, the screw holes, and you're testing it for here, or here. So here, capacitor. This is ground, this is positive. You'll know it's ground positive due to the way they're laid out. See how we're reading fairly low ohms, but we're not reading If I hold this, it'll go down. It'll go all the way down. This multimeter is pretty good. Okay, yeah. So one side, your ground side should read low ohms, 0.3, 0.4, or even 0.9, depends on multimeter and how long you hold on to it, really. This one generally reads 0.3 if I hold it long enough, say 0.3. That means it's a pretty good multimeter. 0.1 would be better, but I mean, you're spending a lot of money. See how we're reading above that? We're reading about 2 ohms. It'll go down to about 1.8 on the positive side. That's fine. There's nothing wrong with that. Now you're getting those readings due to the fact it's the core. The core is messing it up. Messing up the reading, okay? Your core can mess up readings. So even though this is the red to a ground spot, doesn't matter, okay? So I'll just show you. Alright? Don't matter. Now, what you want to do for those testing, if you give me a second, I'll grab a card that's fairly similar to yours. So here's my modified GTX 1080. Also, a Strix, okay? So it has the same VRM layout as yours. Alright? Same VRM layout. Alright, you still with me, buddy? What you want to read upon with your multimeter, hope I can get this laid out properly. Okay, glad you're here. What you want to be testing are your rails first off. Always be reading your rails. Okay? So what you want to do, to any ground spot, any of these holes is a ground spot. You see the capacitor where it has this dark line? That's a ground. That side's the ground, okay? That side's the ground. Alright, so any spot you have a ground. So do what I'm doing. You can literally just let that sit there. And give me a second, I think I can show this a bit better. Alright, we'll lift this up. There we go. Okay, there we go. What we'll do, put this down, go. Okay. So again, hold your multimeter together on resistance to make sure we're reading what we're supposed to be reading. I have to adjust my wires here for this for some reason. But yeah, whatever we'll read lower, the 1 ohm. 0.1, I mean, that's insane. What multimeter do you have? I mean, that probably costs you like $500. But yeah, if it's reading low ohm, that's good. All right, so you try to look for that. Yeah, that's ideal. 0.1 is fucking amazing, dude. Amazing. So what you want to do, find any spot that's a ground. All right. Another thing you can do to make sure you're not shorted out if you're on metal is to put it up on something. I already know I'll be fine because this is painted. But yeah. So any spot that's a ground, just put your one probe. All right. And then you're gonna read your rails. All right. First off, what you could do is straight off of your 12 volt. It should be around 400, and then it'll go down. Same thing with the other side. It'll be high, mega ohm. Don't matter. Next off, you're gonna go down to your PEX. This is more or less gonna be your PEX rail, or this could be the PEX rail over here, but one of them. You'll read 0.800 or 0.800 kilo ohms roughly. Oh, the name brand is Ideal? I'll have to search it up because 0.1 is freaking amazing, dude. The other side should read the same, okay? Same rail. This is a rail. These little things will help you indicate rails. And if you need help, I can zoom in here. Oh, this way. Oh, wait, too far. Come on. This way. Oh, wait, I'm going the wrong way. I went over here. There we go. Okay, so now we can go over here. Go off of the one down by the PCIe lane, which could be PEX, I'm not even sure. I'd have to check the board again. Wait, what? The bottom one down here, the 1RO, you're reading what? Because you should be reading around 100 ohm off of that one. Right around 100 roughly. Yeah, that sounds more, yeah. I was gonna say, that sounds more appropriate. Anywhere from, I believe, normal 65 to 150, depending on card. Okay? It depends on card. This is a 1080, so it's going to be a little bit different than yours. But yeah, 113, perfect. Okay? So, perfect. Alright? Now, there's going to be one up above that. Just up above that PCIe lane. You should be reading around that 900 to 1 ohm. 800 to 1 ohm. Or 800 to 950 or 965. Somewhere around there. Again, it varies. Perfect. Okay, so you're good. Now, go back down to this one down here by the capacitors, by your VRM. And check. It should be around the same, or same as the one over here, fairly close, around 800 to 900 ish. Again, depends on card. Yeah, okay. That's fine. That's fine. Just for verification, check the other side of it. It should read the exact same. Okay, roughly the exact same, plus or minus 1, 2. Okay, perfect. That's what you want. And just double check each one. The front and back should read the same. Okay. Should read the same. So yep. For me, that's the same. Perfect. For me, the same for front and back, front and back. Next, what you want to do too is your chokes, inductors, chokes, inductors. Now, again, your VRM, your 6 down below, I believe this is 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, it's an 8 plus 1 on this card. No, it's 8. It's 8 VRM for the core, 2 for the memory. That's right. Now, the top one for you is for your memory. You're going to hit your inductor now. Right? Check it. One up top. All the way up top for you. In PCIe lane, top. By your plugs. Yes, you have 6 and 1. That's 6 for yours. I've already counted yours. You have a 6-phase VRM. Me, I have an 8-phase VRM for core. Well, you have a 6-phase for core and 1 phase for your memory. I have 2-phase for my memory and 8 for my core. Because this is a 1080 and it's a pretty beefy. Not even close to my 1080 Ti or my 2080 Super. which is a 12 phase, 12 plus 2. Yeah, your top one though. Perfect. Now go down to the next one. For me, it'll be the third one down for me because of that. This will be for your core. Check it. Check both sides. You should be reading like very low ohms. Squeeze is still here. Well, if it's jumping a lot, scratch into the actual like terminal a little bit. It could just have a little bit of factory solder on, factory flux onto it. Yep, that's making more sense. Yep, you should be reading. You should be reading basically ground, because core messes up a lot of stuff. Next, go down. Next, go down. Again, if you're not reading, just do a little. No, no. I'm sorry, I'm not really showing this very well for you, buddy. Basically, just do a little up down scratchy motion. I'll just get rid of any of extra flux in that, and then I'll read really low. Yep, and just keep going down the line. And check to see if there's any huge differences. If you're getting that jumping around, again, just do a little itch onto it. A little itch. Yep. So all of them are good. So you're fine. Your core's good. Your memory's good. Okay. Awesome. Your rails are good, which is your 5 volt, 3.3, and 1.2. I'm not sure where 1.8 is. I don't know if this is 1.8. You should have these right here as well. Little chokes for the rail. Yeah, this is 1.2. These are 1.2s. Okay, so you're looking good then, if everything's looking good. Okay. Now, to figure out other issues on the card, you gotta look by eye. Okay? Like, you gotta drink a coffee or something and prepare yourself to look into detail to see if there's anything discolored, okay? Discoloration. Clean up as you go too. And if you clean up as you go too, you can just guarantee everything's good and while you're cleaning the card. It's a bonus. Okay? So all that's good. You can go to the back side too and check stuff over. Again, my card is modified, so I got some extras. But just verify everything's good. If everything's verifying that it's fine on it, and then you can also see I got right here. Your controller should be around the same spot, so roughly the same PCB, just a little different. This is your ADP controller, and these are the two R2s I have on the card, so that way there's no power limit. Yeah, just go over everything. And then you can also check your PCIe to see if there's a short in the core or anything like that, but there isn't. I already know there isn't for yours because yours is just artifacting. So you don't have to worry about that. The main issue is if, let's say, you get a dead card from eBay or something like that, you got to do testing on your voltages onto like your card, your 12 volt and 3 volt, and there's multiple pins you got to do, like fourth pin over or first four that you just check every single one, or you can just check every single one. But there's traces that go to the core, traces that go to other parts, and it can let you know whether or not you have a short. Yours, you don't have to worry about that, okay? And you just don't. You don't have to worry about it. Don't even worry about it. It's just, it'll be wasting your time, because it's not your card's working, just artifacting. If you go over everything, clean it up. Clean up as you go. What could happen with your card is you got a little bit of dust on a capacitor or something like that, resistor, a little bit of dust, and dust can contain grease, which happens, okay? It's not like it's the end of the world. As you clean up and then you check everything over, okay, everything's good, and you're all cleaned up, rethermal paste it, put the cooler back onto it, and then load up the do a DDU if you wanted, but make sure you got the latest driver onto it and check to see if it fixed it, because cleaning up the graphics card can fix issues as long as you checked everything over and you've already checked the rails, you've checked the VRM for your phases, everything's fine. Your readings are perfect, okay? So if everything's reading nicely from there, visual inspection's good, it could just be dirty card. Literally just a dirty card. If after you've done that and it's still artifacting, let me know, because it's very difficult to actually pinpoint an issue because there's so many capacitors, so many resistors in that without voltage injection. And no problem. Voltage injection is what can really help it, and you need a small voltage injection of 1 volt with 2 amps or 5 amps, depends on what you're actually trying to look at, and you need a infrared camera. Like, it's not, or you can also use, you can use rosin. It's a technique to heat up rosin flux to make smoke that goes over top of the board, to where you use the voltage injection in that little spot wherever there might be a short, which again, that's a short. Yours is not shorting because your card technically wouldn't be working. Yeah, thermal cameras. And thermal cameras, the cheap ones that I would recommend are $500. The cheap ones. Yeah, but that's shorts. Isopropyl you will not be able to see with anything that might be heating up due to it, being defective. Memory, one of these memory capacitors can go, and maybe will be affecting one of your memory chips, but you can try a reflow. It's just do it carefully. Protect your capacitors. Right? Put something in front of the capacitors, like a piece of metal or something, so that way they don't get oversaturated in heat. They wear out and they can explode. So very careful there if you're going to do something like that. Okay? But yeah, your card seems fine. And from all the tests, pretty basic tests in my opinion for that. Yeah, no problem. Like, I need a voltage injector, to be honest. I need a bench power supply that does voltage, that I can do voltage injection, because I want to fix my GTX 1080 Ti. I took it apart one time after benching because I wanted to do some mods to it, and I took it all apart, everything, and then I didn't realize someone might have done work to it before, and there was a ball of solder, and when I plugged it in to do voltage readouts, that ball of solder must have hit something and shorted it out and blew a bunch of stuff. It blew I'm glad I had it, but it blew the fuse for it, and I'm trying to figure out what's wrong with it, but I need a voltage injection to clarify what could actually be wrong with it. I try to break it down to make it simpler. A lot of people like to just talk about this, that, what it does, like this. It's do the basics. Do basics, make it simple. A lot of people don't make it simple. They just talk and talk and talk and talk. And they go on one topic and then go back on the same topic. It's like you're not helping the person understand things. So again, your rails are the main ones that you want to worry about, because I'll let you know if something's shorted on that rail, specifically that rail. And if you're on that rail that you're testing, like this rail, this one, or this one over here, there's only so many rails. So when you're testing them and one of them is shorted, you can just work off of that. You can backtrack on that rail, on what is actually on that rail, and you can even search up whether or not that rail is your 1.8 volt. Well, your 1.8 volt will go to a controller of some sort, a controller, like a little black box controller with some legs onto it. That rail could go to a transistor, like a 3-legged transistor, and you can check that, see if it's shorted, like this little guy, that right by your memories, which these can go to, but it's very, very rare. Yeah, you can literally trace back, because then you're not looking all over the board going, oh, well, we can test this, we can all test everything here, instead of, oh, just test the rail, oh, I can just test this section, because this goes to here. And then I can just keep going back and back tracing from that. That's how I figured it was wrong with this card. After I did one of the modifications for the switching frequency, again, I did a Fernmark test and I blew up a MOSFET. At the time, I didn't know. I didn't know what happened. I blew up a MOSFET. And I did back tracing. So I went from, because I was getting a short from ground. I was only getting on one of the 6 pins. I was only getting on the top one, not the bottom one. So I was getting a short from there. Well, go back from this one here and just trace back and test the components. Flipped it on the other side. Okay, well, that component's shorted out, fake short out. You can get fake short out, so something seems like it's shorted out, but it's not. It's something down the line. So I took off 2 components, was like, okay, well, that's not it. And since this, and then testing it, so you can test 2. So you got your 6 pin or 8 pins, double 8 pins, triple 8 pins, 2 6 pins. It don't matter. You got your 12 volts in with grounds and some data sense lines. Blah blah blah. Okay. Now what you're gonna do is hold your. It's always the inside to that to see whether or not you got a shorted MOSFET, and you're gonna test it. I can't touch it. There we go. And you can test it to see if 12 volt is shorted to that 12 volt, because the 12 volt's technically grounded. So if I have power, if this is power and I'm putting it to the power, I should be reading low ohms, but sometimes it won't read low ohms. It'll read higher ohm, which means you'll know that there's actually a short, and you can test each one. One of these 8 pins or 6 pins could go to one portion of the VRM, and the other half of that VRM, or a couple of that more VRM, could be to the other pin. So this 8 pin probably goes to the memory and a few of these VRMs. I'd have to do some testing. But the 6 pin probably just goes to these other 4 phases. That's it. And this 8 pin does the memory and 4 phases, because it's an 8 pin. It can handle a little bit more power. It gets split up, but you'd have to do testing. Don't test the ground. You want to test the power to each. So power to this. Reading high ohms, nice. Reading high ohms, nice. Reading lower ohms. Reading lower ohms. This one is reading same. So, is it down here we might need? Yeah, so this 6 pins definitely going to the memory. Yeah, definitely going to the memory. And maybe to a phase or two. Maybe not. Test over here. Yeah, that's fine. Definitely testing it for that. There's no way that 8 pin's going to that strictly to the core. There's no way. I don't know. I don't know these IC MOSFETs. These IC MOSFETs are a pain in the ass. That power distribution, yeah. Yeah, and yours, yeah, so that would be more difficult for you to test. Okay, that'd be harder for you to test. But you can test each 12-volt section as well. Number your top 8 pin. Your first one will be ground. Your next one will be data sense, and then the next one will be ground, and then this one here is another sense pin. You only have the 2 ground points. Your bottom, though, will always be, for your 6 pins, full 12 volt, and then the first 3 from the one side here, this side. Oh wait, maybe it's backwards on this one. Because, yeah, it's backwards on this one. So technically the top rail is my 12. The top rail is technically my 12. So the top depends on, yours should be the same, the way they're connectors, because, again, they switch them fancy. So we can do this. Oop. Yeah, on there. Yep. And test over here. Test this one. Yeah, that seems better. Alright, so yeah, this one. Yep. Yep. Maybe they're working in unison for this. We'll go over this one, which is also that's fine. Yeah. And sense 3. I'm reading correctly here. Nope. Let's figure this out. Multimeter does not like my old wires. I like my old wires because they're already worked out for everything. There we go. I'm reading correctly again. I have to have it positioned. I might just have to fix up the actual whatchamacallit. So we're reading good. Yep. All right. Calm down. Sure, reading good still. 4. Yeah. 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 Could be working in unison somehow. It is what it is. One for one from one pin to the plug, 2.9 from the other one phases. Yeah, and that's good though. I mean, it's reading no shorts. That's basically what you're reading on that. I'm trying to figure out why I'm reading. 0.8 mega ohm. 0.8. 0.8. There's data sense, so no, it's just, oh yeah, these are all 12. This one though, crappy, really high. Like 4. The whole it should go all the way down. It's data sense, so probably just reading off. Yeah, and then because laptops are even more of a pain, and testing on CPUs is even more of a pain. The core of your GPU, your CPU, again, laptops really suck. It's a pain because the core can mess up your readings. That's why if you don't have a extremely high end certain it's a special low ohms multimeter specifically for low ohms reading. They cost $500 and does one job. That's it. And even still, it can mess up for some cores because the core architecture, however it's wired in there, all that, because of how dense everything is, it can literally jump the reading because of how tight the actual architectural is. The transistors are, how small everything is. These are 12 or 14 nanometer. The 1000 series. 12 or 14 nanometer. Or am I wrong on that? I should be right. Somebody want to search that up? What size transistors of 1000 series GTX GPUs? 12 or 14? Yeah, even though, because this technically is putting some voltage through, right? So that way it can read, right? To read resistance. Because of how tight the architecture is on these newer GPUs, and yes, it's still technically a newer GPU, it can mess up your readings if you're not, paying attention. So you don't want to just be like, oh, it's slightly different. No, you're looking for major differences between each phase, between each component. And even still, your multimeter, if you don't have a specific multimeter, that's why voltage injection for finding shorts is key. It's just a go-to because you can just use 1 volt, 2 amp, or 5 amp. Generally, you just want to go to 5 amp, but 1 volt because the core can handle 1 volt. It can technically handle 1.2 volts, but 1 volt's enough. 1 volt at 2 amps. And then that is enough amperage with enough volts that it can warm up the component if it does have a short. That's why voltage injection is very handy. Because the core can handle it, the memory can handle it, everything can handle it on the board. Can technically handle it, except for a short. A short. So basically a short, let's say a capacitor, right? A capacitor, it's supposed to allow voltage in and have a ground point. This is shorted. Well, guess what? The voltage goes in and just the component gets hot because the voltage can't go anywhere. Done. But you've already tested it all out. So again, just clean up your board really good. I don't know if you need the card right away. I wash it with water and a brush. Wash it with water and a brush. And then after you're done, rinse it off with bottled water. So that way you don't get any soap stains, more or less. Or soap stains, mineral stains. If you have hard water. Calcium stains, mineral stains. And just wash your board with a brush and water. Brush it with hot water too, and it'll be even better. Not boiling water, of course, but hot water. And you can get it nice and clean. There you go, perfect. Yeah. Then you can wash it up and then just let it dry. And if you really want to make sure it's nice and dry, just dump some isopropyl over it. Let it dry off for a few hours before you even start testing. Or wash it with isopropyl. Perfect. Not gonna harm any component. You can literally soak it in isopropyl for a week. It's not gonna hurt it. And isopropyl dries very quickly, right? So. Main thing, clean it just in case dirt is on some small component of some sort, a resistor, capacitor, and it's just causing interference to the memory. If after you've done all of that, then yeah, maybe you could do a memory reflow and it could help. But then it's hard to tell. It really is without testing everything, because the transistors or the voltage regulators beside the memory chips could also be faulty. A resistor, a small little resistor, could be faulty, but it's also like, well, technically it works, but it doesn't work because it's actually resistance is changed from what it should be, and that's when you need schematics so you can go through and check. I can't use mine. I can't be like, okay, you can use mine. If you had a brand new or a perfectly working GTX 1070, the same model as yours, then you can just check off of that donor board, check it, and then go to yours and check it. But that's check. I mean, it's a lot of work. Yes, GPU sag can. GPU sag because of the way it holds into it, right? Holds into it like this, into the slot. If it sags down, and sag can actually cause issue with your BGA, as in it can crack it. You crack it. Because your GPU gets hot and cooled down and GPU sag happens, it could sag down while it's hot, and when it's cooled, because of all the copper that's in it, your board could flex a certain way to where the BGA has cracked. Also, too much sag, your PCIe lanes could not make in proper contact. Yes. So that's the reason why this card was artifacting extremely hard to where it wouldn't even work. Like, it worked for like 2 seconds when I first plugged it in, and then I tried to do it afterwards, it never worked again because it's artifacts so hard. And that's because of this style of blower style cooler. With the way it's laid out, with how hot these get, the copper that's in throughout the board warps the board a little bit. You can't really visually see it that much unless you really check. You can see a little bit. But because of the way it's laid out and how hot things get, and because of the way the pressure mounts are on this, like for the core and where the memory is, and it gets hot and twists, the board twists because it's hot, cold, hot, cold. This spot's hot, this spot's cold, blah, blah, blah. It can actually crack the BGA. Yes. I've got my 1600 that I just started shimmering. I lowered my monitor refresh from 144 to 120. It stopped for now. What do you mean by that there, Sing? What do you mean? Yes, and there's a lot of copper in your GPU. There's a lot of copper. I've shown this on another stream actually. Just give me 2 seconds and I can show you what I'm talking about. And it's easier to show on this one GPU, to be honest. Why is it easier? Because it's red and it shows the PCB. So, what I'm talking about here, give me 2 seconds here so I can zoom in. Don't mind the cat hair because it has been sitting on the floor here. Let's just some cleaned up. Now, if I go to image and then change the contrast and saturation and the sharpness a little bit down right there, and then the hue. Okay, now it's a little bit off color, but now you can really see what I'm going to talk about here. Like our fact, but it's very faint and looks more like how, yes, because you went down to 120 hertz, you're not stressing out the memory as much. So you might need to take apart your card and clean it. That's a first step that you should really be doing, unless you got a multimeter, and I can go through some steps so that way you can test some stuff. Since it's technically working, the multimeter is not going to help you out, unless you have a donor board and all that. But make sure your card is clean. Having a clean card can just help you troubleshoot some problems. So, over here, see how we got this color here? And we got these darker colors here. I wonder if I can go back to the red and you can actually see it really good. I don't think so. Oh, yep. So there's the color that should be. So, see how we have this lighter color? And we got these darker colors. This lighter color is all copper underneath this epoxy layer. All this is copper that you can see. Now the traces. The traces, you can see that they're lighter colors. That's all copper, right? And then underneath the next layer would be another plane. And they're planes that I'm talking about here. So this plane is all copper. And that plane is generally ground. Okay? And how can you test if it's ground? Again, you're going to go to some spot on the ground and you're going to test this. You'll get low ohms. So here, and I'm going to touch that spot that I scratched away. Low ohms. That's a ground. And that whole plane, and you need to learn this kind of stuff when you're modifying graphics cards, what is a power plane and what's a ground plane, because not all of this will be a ground plane. But this is a ground plane, so if you need a good grounding spot, you could just get rid of some of this masking, like scrape it away, Dremel this out, whatever you got to do to remove this masking, and you got a good spot to solder wires or whatever you got to solder to for good grounding. Good grounding is a good thing for modifying. So that's how you can tell. And then you can go over to another spot, be like, okay, well this goes from here over to here. Well, this is the plus, and that plane there goes to that. You can scratch that away and see if that's an actual power, like 12 volt source or a 3 volt source. Generally, it would be a 12 volt source for the first layer, but you test it. Yes, and also, have you taken it apart to see if you have any kind of condensation onto it? Might have leaked a little bit of water. Could happen. Could. Never know. But yeah, there's a few tutorials. Okay, what do we got here? There, you got picture. Yep, that's your ADP. Yeah, that looks like it. So from your 12 volt source,
if you power on the card and put your multimeter to DC voltage and check that capacitor, it should read 12 volt. And when you put a 2R2 on top of that, it will trick the controller into thinking it's not using as much power, but it won't put it into limp mode with the 2R2. And I've already done it with 1070, like, oh man, so many GPUs. 2080 Super, 1070, 1080, 1080 Ti. What else do I have? GTX 770. I not with this card. The 460. 460 is completely different. You gotta do a lot more modifications for it, or harder modifications, and understand more technically for the GTX 460 for that, because the NCP 5388 controller is annoying. And then your controller will be a UP9515 or 99512 S. It'll be an S though. I'm going off of memory. My memory's pretty good, but to remember all that kind of stuff, I try not to, because it just takes up room in my brain, and I don't want to fill up my brain with controllers when you can just search it up or look at it. It's definitely dry. I've got a 9070 XT water blocks on the way to swap. Once I have the CD100 out, I can do. Okay, yep. If you need help with diagnosing, let me know. You can only do so much with what you got technically, and then again, unless you can find the schematics, and finding schematics for GPUs is not easy. And then once you get the schematics, you're gonna have to test every component basically that basically I don't say to do, which is all your rails, your voltage rails, which are the easiest things to do. And the voltage rails is just to find shorts. To test each component, you actually have to test each component. And sometimes when it's on the board, it might be reading off, but as soon as you take it off the board, it's reading wrong, or reading right. So sometimes you have to desolder that component to actually fully test it proper, which is also annoying. And then when you're also testing some components, that component could be in a series. Well, if it is, well, how? Oh my god. Because you could test something over here that's shorted, or, yeah, basically shorted or wrong, and it could be affecting something over here. Depends on how it's laid out throughout the PCB. Yep, mem chip could have faulty solder. It happens. It happens. A lot of it's due to design of coolers, which generally would be fine, but then let's say you don't have a support bracket onto it, or it got really hot in your case because you have terrible airflow. That's why I try to recommend certain things on my channel. Certain power supplies, certain way to set up your fan cooling, certain everything. I don't care. I'm not biased for any kind of brand, AMD, NVIDIA, or Intel. I'll let you know what will work better for you, for your budget. And if you like AMD, I'll let you know what's good. If you like NVIDIA, I'll let you know what's good. Yeah, especially after a water block. Yeah, my 2080 Super. 2080 Super. It's the EVGA Hydro Copper for the win. They weigh a lot. They really do. Yeah, massive. Yep. Uh, I didn't check to see how much the MSI Lightning weighs. I bet it weighs quite a bit too. 40 phase VRM. Give me a second, Nugget. For the water cooled. Okay, yeah, well, you don't have to worry about PCIe lane then. Even still, let's say you have good cooling on your CPU and your GPU, the components on your motherboard can get hot. If you don't have good airflow. That's why having a fan on your RAM, an oversized fan on your RAM, or a good RAM cooler can actually be beneficial because it can cool more than just a RAM. Just giving that little bit extra air onto it's good. I mean, it sounds like you got a dang good system. Right now, my system, I've just been using 2080 Super for a while. It's double custom water loop, 13900K, custom monoblock, cools the motherboard and the CPU. I don't care about VRM. There's more components than the VRM. Mine cools a VRM too, but I have fans on the board itself, cooling any small component, any small little component. I have a fan on the RAM. There's actually no point to have water cooled RAM. It doesn't help at all. Just keep it, cooler. Not really much, but does keep it a little bit cooler. 6000 XT, I would like that. I had the 6700 XT way back, but I wish I never sold it. I liked it. I liked it a lot, and I wish I had it so I could do more benching and modify it. It overclocked pretty nicely. Oh, you guys are distracting me. I was getting this set up so that way I can get the video capture device motherboard set up. Actually, it's already set up. Video capture device, get this set up so that way we can see if it's artifacting. I don't think it's going to artifact anymore. Distractions. It's okay. It's the reason why I started this channel and did PC stuff, because I wanted to help people out. Teach some people. That's all good. I like to stop my stuff and chat, and that's why I have it, so that way I have low latency for my chat. So that way I can, talk back and forth quicker to you, so that way you're not waiting 3 or 5 minutes for a response or not even getting a response. I'm here to help. That's why I have this channel. That's why I do this. Am I the best at this kind of at everything? No, but if I can help you out on what I know, I will. If I say I don't know, I'm sorry, I don't know. I will teach myself onto it so that way I can maybe later on help you, but if I don't know, I don't know. My memory's pretty good though. You can ask a bunch of other viewers like Guh and Vep. There's people that haven't come to my channel in a long time and they just show up. You remember me? Yeah. You came to my channel first at this day here, as around this day here, or this month here, around this time. Yeah, how do you remember that? I don't know. I just do. I gotta go feed the nugget and I'll be right back. She is getting hungry and she's screaming at me. Yeah. So just give me a minute. If anyone has questions, let me know. If anybody's wondering about modifying GPUs and getting into hardware bot for records, or just wanting to learn more about hardware, whether it be GPUs, CPUs, RAM, and motherboards, I overclock it all and I modify it all. So I do know quite a bit, and continuously trying to upgrade my knowledge on everything, basically. Yeah. It's odd, to be honest. It's odd how the memory works. A lot of times I try not to remember certain things, but then I can still remember it, or parts of it at least. It's like I don't want to remember that, but I'm remembering it. But it is what it is. No, let's get you some food. Yeah. Well, give me a second. I gotta open it up. Patience. Patience is virtue, kitty. So I'm going as fast as I can. I'm going as fast as I can. Oh, we got the good stuff again, yeah? There you go. Wait. Sit. 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 Wait. Wait. I said wait. Wait. Ah. I said wait. Wait. Good girl. Good girl. Freaking out. You got fed at like 5. I don't know why you're freaking out now. You got fed at the right time. What is up there? What's up from Iceland? Oh man, you're Iceland. What's his name? Hold on. Give me a second. I got it here somewhere. Don't say nothing. Just give me a second here. You're Iceland calling. Calling. Iceland calling. Running 111. Running 1-1. Iceland calling. Yeah. Yeah. You said your name, but it's like, yeah. Why isn't this card running my LLM? Yeah, yeah. This old 1 GB card. I would like to upgrade the VRM to 2 GB. I just don't know if the memory controller would be able to handle it. But I would like to upgrade the memory to 2 GB. That way I can run some certain benchmarks on Windows 10 and not have to go back to really old Windows. I'll be right back though. If anyone has questions, let me know. But yeah, this is the GTX 460. Basically got every modification you can think of. Well, it'd be a very small Grok model, and it would probably take 10 years to finish, because this thing is 16 years old now. Yeah, Mark, yeah, 16 years old, almost to the date. 16th? Yes, basically 16 years old to the date. I think it came out in the 20th or 24th, though. Pretty close. Yeah, one token an hour, exactly. Should make myself some food too. How long have I been streaming for? Don't even know. How long have I been streaming for, guys? We made it to 1,400 subscribers. Let's go! And I'll get this card set up here in a minute. You're gonna have to give me a minute. 6.5 hours. That's short stream so far. That's a short stream. 1,400 subscribers. Let's go. Let's go. Okay, so yeah, I'll get this all set up. I'm gonna make myself some food though. It'll be very quick. Very quick. Oh, and get some water while I'm at so I can make another coffee. I gotta get the video capture device set up. Card plugged in. What magnification optics are you using so we can observe? Oh, this is just my camera. The OBS bot Tiny Light 2. Nothing fancy. Nothing fancy. And it's, you know, not exactly close right now, so it's not very good, but it works for now. Till I can afford a better camera, like an actual camera that has optical zoom. But it works. I just got it set up on a tripod right now for doing all this stuff. But I'll be right back. Ugh. 17.2.49, you got an artistic. Yeah, if it's with Core Ultra 7, it's going to be DDR5. I don't think it has DDR4 support. Don't believe it has dual memory controller, just single DDR5, from what I remember. Wait for the food, so I'm going to make myself a coffee. Coffee. Yep. Yeah, so your 12th, 13th, and 14th gen have dual memory controller, DDR4 and DDR5. Those are only CPUs that I know of that have it. And Core Ultras don't have it. Now the new Core Ultras, Core Ultra 270K seems to be a good budget CPU. Does seem to be pretty good. Yeah, 1 TB is kind of weak. Yeah, not gonna lie, that 1 TB is terrible. For how much? 1900? That's US too. Oof. Yep, it's 1851. It's just a refresh of the Core Ultra. That's why there's an S. People are freaking out about the S, thinking it's a different architecture. It's not. Same architecture of the Core Ultras. It's just S as in it's a refresh. Like the 14900 are refresh of the 13 of Raptor Lake. And then the 270 seems to be pretty good for budget. 299, and then the is it 260? Or is it no. Yes, 260. The 260K? It's 250. But yeah, it's LJ 1851. Nova Lake is gonna be on 1954. That's gonna be the new CPUs. Like the new platform, 1954. Seems to be pretty good too for Nova Lake. The refresh looks really good though. Of the Core Altus does look pretty good. Yeah, 250 and 270. Yeah. Thank you. Oh, thank you. So I'll get the video capture device set up right now. I gotta wait for making food, unfortunately, but at least I got some water. We need this. And then we need to add a video capture device. And then we can do this. Hey, there we go. Hey, Fonzie. Hey, look what we got. I don't have a keyboard plugged in yet, though. So I gotta plug in the keyboard. I do have a keyboard plugged in. Boom! Oh, I didn't want that. I want... Boom! It's only going to be green for a bit until we get a driver installed, and it's going to take a minute for... Oh, I need... Wait, what? Your best and for support? What? Oh, I need to plug in the other RAM. Maybe that's the issue? Maybe. Your best engine not fully support the boot. Oh. Oh. Well, that'll do it. That'll do, donkey, that'll do. There we go. Hopefully this is the correct drive. Yes, it is. Okay. We're good. We're getting somewhere. Hey! Now it's going to take a hot minute for it to get the to get the driver. So we'll just give it a minute here. No artifacting yet. Uh, Oh, we got the driver already. Let's go. Yeah, I need So older hardware on this video capture device. It's a decent capture device, but certain older hardware needs to have a driver for it to have color. That's all. So that's why I said we have to wait for the driver, and we got color. And we got driver. We can do some testing. Well, I'm gonna reset PC, and hopefully it loads up better, quicker. Okay. And then again, there's no driver loaded, so that's why we got that. F1, just give me 1 sec to do that. Blam. I calls for parent pay. Go, my coffee's ready. I got stir my coffee here. Let this do its thingamajig. It should load the driver pretty quick this time. Yeah, there we go. And go. All right. And now I have to switch over to this. All right, we got the mouse now. Now I should be able to put this down to like 900 at around 800. And we'll put the fan speed up too. Temp should go down. Nice. Yeah. AM4 is still good. Yeah. I mean, it takes time. It took me a long time to get all the hardware I have. Awesome. Now we should have Benchmate here somewhere. So I could do a test. There it is. Buy used if you can. Always buy used. Ooh, I got the temps pretty good. Temps are pretty good. This is on air. 50 degrees? Oh yeah, we fixed her. We fixed her. We got her chooching now, boys. So we're overclocked and undervolted. How far can I push the memory? Can I do 2150? Probably not, but I'm gonna try it. Oh, I can. 2150? Oh yeah. Oh yeah, we're chooching. How far can we undervolt to 800? I don't think maybe 850 will work. Let's see. Nope. It did not like that. I'm sorry. Gotta love making a profit. 960 Viva 590. That fan, yeah. Yeah. Boom. Yeah, it's a good deal. I have to restart the PC. It's gonna take a hot minute for it to be like, I don't like this. It's doing good though. This is awesome. All right. No artifacting. Seems to be doing pretty good. Yeah, VRM doesn't matter though. My 3070 Ti matches a 9070 XT. No, no, it doesn't look pretty good. Not in my opinion. I don't know how my 30 series 3070 Ti matches a 9070 XT, but it does. What driver did it load? 380. Not the newest, but that's fine. So this is stock 1.037 volts at 763. We're doing 900 at 800. And we're doing, can we do 2200? 2200? No artifacts at 22. No artifacting, I like that. Okay, so let's put some stress on it then. 900 millivolt, 800 megahertz. 5070 is 50% more cost? What? That's crazy. Yeah. Yeah, to find a good deal is still a good deal. Okay, 22 on memory, 800, 900 millivolt. No artifacting off the bat. Temps don't look half bad either. I'm kind of impressed by that. That's fine. I don't mind. It's invalid. I need 925. And let it cool down. $1,500 for a 5070? Where? Where is it that price? That's wild. That's terrible price. Ah, in games that are optimized for AMD, the 9070 XT will crush the 5070. But not. There's only a few games that are fully optimized for AMD. And then you start adding ray tracing. Yeah, that's when NVIDIA starts coming ahead again. Yeah, you should be able to find a 5070 for like 800-ish. New. You're spending more than that. You're smoking something. Whatever you're smoking, I don't want. Yeah, Newegg can be terrible for pricing. Yeah, and you should be able. And that's what model? What model is that? The temps look really good. Undervolted and underclocked. Memory's at 2200. She fixed. PNY. Is that the triple fan? Yeah, triple. Okay. Oh, almost finishing it though. Max temp 59. That's really good. Okay. So what about 3D Mark? Memory at 2200. Oh, hold on. Go. Oh. Uh, well, that's fine. I'll let it run. No artifacting, still running. Slide over. It's nowhere close where it should be, but I'm happy. I'm hoping when I do chilled, I can get up around 1.2 to 1.3 gigahertz. I can do 1.3. Only a few of these cards in the world have gone up there, and only one at 1.5 on LN2. Yeah, man. This is benchmarking. This is for records still. We still use it. It's more CPU oriented now. A 13th or 14th gen, like 1300K, or even a 13600K or 13700K with the P core, 3P cores, cranked up frequency with a GPU, get good scores. It's passing though. I'm happy. I just want to know how hot the one MOSFET's getting. Probably not bad in this test. That's why I want to make heat sinks for it. Or at least get some heat sinks for the VRM. I would have liked one of them. I would have. They sound way too much now. I mean, some of them are like $300 that you can find, but for the really rare ones, nah, man. You're talking like 5 to 10 grand. A little bit of artifacting as temperature goes up, but still good. Is that 2200 temps are not good on the memory, so. Plus the memory is over voltage right now. And I should see what the memory voltage is right now. It's probably around 1.65 volts. Or is it higher? I don't remember. I'm gonna test the voltage. Give me a minute here. Yep. Yep. 1.65 volts. Which wasn't it's not bad. It's not bad. Fairly close. Fairly close to stock, so I'm happy. Happy with the fix. Just needed another refill in the memory chips. I don't want to push it too hard until I get some proper cooling for the MOSFETs. Because with the switching frequency at 920 kilohertz, they get hot. They're probably quite warm even in this test, so I don't want to push it. And then once we see the turtle, which will be coming up here, this is the hard part of this test. So, oh god, I forgot about these tests. I should just exit because these aren't needed. Watch your eyes. I don't know why they ever made tests like this in this thing. Like, apparently epilepsy wasn't much of a worry. Reflections. Yeah, where am I? This is a reflections test. Another reflection, so high polygon reflections test. That's high definition too. This hits the memory pretty hard. Yeah, trash. It tried. It's probably getting pretty warm though.
temp did we hit? Yeah, almost 70 degrees Celsius, which is still really good. That's better than stock. So I'm glad I sanded down the block there. Sweet. That's pretty good. I'm happy. I'm happy. Wattage. No wattage. Of course. Still happy about that. And actually, it might have been CPU that went there too. The CPU is 1300K on a crappy, basically stock cooler. So I let it cool down a bit here. Let's do a 3D Mark 03. That's as far of a test I want to push it until I get proper cooling for it. Because it didn't fully crash. It didn't crash the GPU, as in generally this will go into limp mode, like yeah, 405 to 1900. But it's not. It's not in limp mode. See, still boosting. So now I gotta run 3D Mark 03 for me. There you go. Nugget. Now we only want the GPU tests. That's all we need. GPU tests. Okay. Run. Nah. Didn't pass. And that would be core. That wouldn't be memory. No artifacting. So I'm really happy with the memory though. And it might have been still going, but I'm actually. Sometimes it can just crash like that, but not fully crash and actually run the rest of the bench. Just gives false information. So let's do 950. And that should pass. I need to probably exit that out and reopen it. And sometimes crashing will make it go, why are you doing this? Oh, did it crash out on me? Nope, we're still good. Alright. See, it's 1 gigabyte. It's got Hynix, 1 gigabyte. I like to make it a 2 gigabyte maybe eventually.
select, boom, boom, okay. Give it a minute to cool down. Alright, let's see what it does. See if we can pass that 950 millivolts. Should be able to. But all in all, I am happy. I am a happy camper. I can go back and try to get some more records with the card. Advantage might put too much stress on it. It's just because the switching frequency is so high. Everything runs hot. Like the MOSFETs run hot. The chipset runs hot. The IC4 switching frequency per phase gets hot. And since it's on stock cooler right now, I just don't trust it. I don't want to blow up another MOSFET or some sort of controller. So I'm trying to do light tests. But the memory is fine. Memory's overclocked 2200 right now, so it's good. At 1.65 volts. Core is at 950 millivolts at 800 for frequency, 800 megahertz. It's pretty good. On stock air cooler. So I'm happy. Before the car would be running around like 80 degrees, 85 degrees Celsius. Now it's only hitting about close to 70. So I've dropped temperature even though it's back on stock air cooler. So that's good. Looks like it's gonna pass this time. Controls layer though. Once we get inside near the end is the hard part. Yes, Nugget. Ah, yeah, see. And it's probably gonna pass it or not. Yeah, see, passed it. And turtle gets hard. Alright, Jason, looks amazing. Yeah. Oh, we're past the turtle. Okay, good. Butterfly. Yay, it passed. Let's go. And 71, 142. That's actually pretty good for a 3770K. That's actually pretty good for a 3770K. Stock. I can't complain about that. It's actually pretty good. What? How's it going there, Dab? We need that butterfly for potions. What temp we hit? Yeah, 72. 72 is our max temp. I'm actually kind of happy. That's not bad. So, yeah, that's not bad. Yep. Yep, we got the GTX 460 working back to tip-top shape. Can overclock the memory, no artifacting anymore. Put more capacitors onto it. A bunch of 0608s, 0402s. Yeah, awesome. Yeah, I think he did. Sweet, 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 sweet. How far I can push the memory. 2257. Artifacting. 2300. 2300. Ready? No artifacting. Oh wait, we got no stress on it. Oh, yep. Oh no. Oh, hold on. Hold on now. Definitely not going to be able to do it, but I'm going to try it. Yeah, I didn't think so. $22.57. Let's go. That's pretty good. Nice. All right, so it's all good. Everything's working fantastic. Yeah, your energy rechargeable for your VR. Oh, nice. It's not more rich fish. You really got the Energizer Bunny, eh? You got the good stuff.
Dude took a token pass up for 24 hours. I noticed you've been lurking all stream. Vep's waking up late. That's not normal for Vep. Man, that sounds about right there, Vep. That sounds about right. That's that's like me. Not that many smokes, but definitely that much coffee, if not more. I've had about 2 liters of coffee so far today. So fairly normal. I say I have more than 2 liters. More like 2.5, maybe 3 liters of coffee today. Hey, lurk away, man, lurk away. Yeah, one, 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 they're a little different, but they do kind of the same thing. Okay, so this is good. I'm gonna try 1 volt, 900. There's no way this will work, but I'm gonna try it. No, didn't think so. You trying to get him to pass out as soon as he wakes up there, Dad? Ball X pit? What? Yeah, over a half a pot every day. Only half a pot? That's like 2 cups for me. Yeah, my normal is like 2 pots.
It passed it, but it shouldn't have passed it. Your old 8 gigabyte 4060 graphics. Yeah, it's a GTX 460, pretty close. How is it passing? It's 900 megahertz at 1 volt. This switching frequency, well, I guess that added caps too. And on stock air cooler, like I am impressed right now. I can't wait to get this thing chilled. I literally can't. Like no voltage, just like no voltage. This is less than stock voltage, and we're up almost 150 megahertz. Less than stock voltage. Yeah, old is the newest, strongest card. Yeah. Oh, I know. I definitely know. I drink more coffee there, Bep. I drink more coffee than anyone I know. You can send me that old GTX or RTX 4060. If it's just a paperweight, you can send it to me, buddy. I'll make good use of it. I like old graphics cards. Oh, you sold it. Oh, dang. Can we get past the turtle? Get past the turtle? Get past the turtle? Past the turtle? Past the turtle? Come on, baby. Oh, a butterfly. Oh, look. The turtle has ADHD. Or ADD. Or both. 3 hours use on it. You sold it. Get this out of my sight. Why did I ever buy a 4060? So last score is 71,000. So this should do pretty good. It's 100 megahertz higher. 100 megahertz higher, 100 millivolts higher. So should be pretty good. I can't believe it passed. Does this actually run the right speed? Or no? Oh, it was not running the right speed. It did crash at the beginning. And now we're... Aw. 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 I should have known. Had my hopes up. Yeah. All went downhill. Dang. Aw. I'm sad. Yeah, probably. It's probably the game. The 9060 XT? Oh my god. You gave up a 4060 for a 9060 XT? I would even recommend the 9060 XT, to be honest. It's not terrible. If you can get it for a really good buy, then yeah. It's not worth it in my opinion though. Alright, well, we're gonna have to restart here. So, 8 gigabyte, there's nothing wrong with 8 gigabyte. My 3070 Ti is 8 gigabyte and it matches a 9070 XT. My 3070 Ti matches a 9070 XT. So if you have a 3070 Ti, don't get the 9070 XT. There's zero gains. If you want to save money, buy a used 3070 Ti. If you're thinking about getting a 9070 XT, because you can pick them up for like $300 to $400. Why would you want to spend $1,000 for a 9070 XT if you can get the same performance from a 3070 Ti? And unless you want new. If you want new, then by all means. If you have the money for it, by all means. Yeah, basically. I was surprised, man. I started watching. I started searching up on YouTube, but a whole bunch of different YouTubers and a whole bunch of different people doing testing on 9070 XT with. We're talking like 98, like the top 9800X 3D, 9850X 3D, 9950X 3D, all the top line CPUs paired with it, and for these games, I literally throw it in with 13900K stock frequency, with P-core only, with 3070 Ti, slight little bit of an overclock, barely any overclock onto it, and it's matching it with around the same watts. I don't get it. I was like, no way, and I started checking out all these other people. I'm like, okay, no, it's gotta be true. Yeah, well, yeah, the 4060, yeah, no, it's just raw. So probably doesn't have enough ROPS in TMUs, ROPS, rastering operations pipeline and texture mapping units, and then also your bit bus width. Again, bit bus width is a big role in performance. You can't blame it on the VRAM. Yeah, you can't blame it on VRAM then. That's definitely more or less the ROPS, TMUs, and bit bus width. Just not enough raw, like actual power. Probably because less CUDA cores too, but this just is not powerful enough. The VRAM was overpowering, basically way more powerful than what the core can actually do. You gotta look at the ROPS, TMUs, and bit bus width. The bit bus width is a main one. So medium tier, your 70 series and up for NVIDIA, and try to go with like the 70 series and up for AMD as well, just because the bit bus width is higher. Don't look at VRAM, and VRAM's only gonna matter if you're doing 4K ultra settings, but then you also need the bit bus width to be able to handle that. If you don't, then well, you can only input so much information and output so much information. Doesn't matter how much information you have stored on the GPU, if that makes sense. Because the VRAM just stores information close to the core for quick access, just like your RAM. Nice phone holder with it? No way. You got a phone holder with it? Where the hell you got a phone holder? What? If it comes with stickers and RGB, you're good. Out of here. Get out of here, Gary. I always see the balls off, but never game 100% usage for hours. Ah, gotcha. I do. I do all the testing for benchmarking. That's why most of the games that I have benchmarks for, I have 1,000 hours in the games for testing. You got a lot of people that have 5 hours in the game. Oh, just do this, do this. Oh yeah, 5 hours in the fucking game. 5 hours, and you're telling people how to set things up, man. Yeah, you worked so hard to get your information. I love it. I love it. Idiots, I tell you. I don't have proper information until I have over 500 hours of just overclocking. Not even playing the game, but playing the game, of course, but of just trying to figure stuff out to make sure everything's working proper, what drivers to use, what like whether or not your CPU frequency is going to matter with the GPU onto it, whether or not your RAM frequency is going to matter, what your timings are going to matter, whether or not the VRAM's actually going to matter more than the core for overclockability, because it varies on games. Oh yeah, oh yeah, you find issues. And once you find those issues, you start trying to figure out how to fix those issues. And then sometimes it's really hard to. AMD, everything was higher. Actually, yeah, yeah, because AMD was selling a decent amount of their cards. AMD has not even sold as many. So Nvidia sold more 4060s than all of Nvidia's 9000 series. 4060s. Not all NVIDIA cards, but just 4060s. NVIDIA sold more 4060s than all 9000 series GPUs than AMD. Just one model outbeat their 9060, 9060 XT, 9070, 9070 XT. Sold way more. We're talking double the amount. Yep. Because you play long hours, you might find certain parts of the map or certain scenarios in the game that are causing certain transient spikes that might cause it to crash. Whether or not it be the VRAM, finally it hits a usage at a certain temperature and it causes it to crash, or it could be core. That's why you gotta do a lot of testing. It's like these benchmarks too. It's also there's different kind of benchmarks, and some benchmarks will hit the memory more than the core, or certain portions of the core with the memory. And then if you are crashing at certain points of that benchmark, then you should know that your memory, if you just give it a little less juice on the memory, you're not going to lose as much performance. You don't have to lower the core, even though it's hitting that certain core, but it's also hitting the memory. And if you lessen the memory, you're taking some load or more load off the core, that portion of the core, which can be stable throughout the rest of that benchmark. And if you really want to do it, you want to set hotkeys. You want to set some hotkeys so that way, when you're benchmarking it, you can just hit a hotkey as it's switching over. You hit the hotkey and it switches the your overclock to the overclock that's more beneficial for that part of the test. Fortnite? No, Fortnite is mostly CPU oriented, CPU and RAM. It's not really a high GPU intensive game. Or it could be hitting certain portions, like certain polygons that's hitting a certain section of the GPU. Yeah, you could be right. It could be anti-cheat, but nah, anti-cheats. Generally, you're fine with anti-cheat as long as you have safe mode. Oh my god, 46 watts with what? On RGB? Okay, I'll try it. I'll try it. Fortnite's free, right? I'll just crank the OC. I'll crank it. I'll do my normal. 2.1 gigahertz or higher on the 2080 Super, and 1200 on the memory, or 1300 on the VRAM. All right, yeah, it's free. Yeah, I'll give it a shot. I'll see if, what could be causing it. Random crash of 20 minutes in the game. Okay, I'll give it a shot. I mean, I said I'll never play the game. I'm not playing the game. I'm benchmarking the game. If you enable all the rages and stuff, get rough. Eh. Better than some free games. Well, it's definitely a big game. Still, a lot of people play it, so. Yeah, I mean it's gotten to be a pretty big game, but from what I know, it's a pretty CPU oriented game. At least the last time I checked, a lot of like more professional gamers that play that game are still only using like a 3060 to play that game. They're just using a high end CPU like a 1300K or 7000X 3D. Most of them are on like Intel though. I'll be back in a minute. Oh, I shut down. I didn't turn it back on. Or did I? There we go. There we go. Back at it. There we go. That's better. Wiggly Boy? What kind of game is that? Alright, stock voltage 900. 2200 for memory. Go 3. Yeah, new drivers seem to be pretty good. So stock voltage at 900 should be okay. It's hard to tell on. Yeah, yeah, dang it. Okay. So let's do 950 at 850 maybe. No, that's it. It did a hard crash. It's only going to 405. It's in a limp mode. Semi-limp mode, no good. It's kind of annoying on these GPUs. Stock air cool. It's hard to tell what I'll be able to do. Stock air. 1 volt. What? What are you talking about, Squeeze? Seems to be passing all right. Nope. Oh. Oh. Of course. Of course. So close. Just so hard to tell what it's gonna pass on. Air, man. What temp are we hitting? Yeah, we're around that 70 degrees. Seems to be not a good spot for it. I don't know. I don't think adding any more filtering caps is going to be beneficial for air. I'll have to get set up on water at some point. But on that note, I think I'm going to end this stream. Yeah, I mean, I'm quite happy still. I'm quite happy with the progress. Plus 9 hour stream. I mean, you can't complain about that. Yep, I'm happy. And tomorrow I might try to get the 8600 GS working. If I can get that card working, or is it the GT? I'm pretty sure it's GS. If I can get that card working again, I'll be really happy. It's got voltage, just not enough voltage to enable it, so if I can get that working, oh yeah. Then we'll start putting over 2 volts into the core again. Let's go. But that's gonna be it for this one, you guys. So all you lurkers, I'm ending the stream. Hope you all have a good rest of your day. Yeah, it was a good stream. I'm actually happy. I'm really happy. The memory's perfect. No artifacting. Very happy about that. Tomorrow, if I do decide to work on that 8600G GS, it's gonna be a pain in the butt to figure out what the issue is, but if I can get that working too, oh my god, I'll be so happy. But yep. Hope you all have a good rest of your evening, or day, or morning, or wherever you're from. Hope you're having a good one. I'll catch you on the next one. And again, as always, don't forget to get her done. Peace.